So we're going to start this Fast API series, and today we're going to learn about how you can build a Fast API in just 5 minutes. So we're going to develop a small API using Fast API. So I'm going to show you how Fast API works, and we'll learn the syntax for that and how to run that inside our local host. So let's begin. So first of all, to run Fast API, I'll just activate a virtual environment for my Python application. So if you do not know how to make a virtual environment, you can run this command python -m venv and then venv, and that this will make a virtual environment inside your folder. But if you do not want to use virtual environment, that's okay. But I use it for handling the requirement conflicts in my system. So I'll just activate this virtual environment by running the command venv/scripts/activate, and this will activate my virtual environment. All right, moving forward, I have a fast API folder developed here. So I'll just go inside this fast API folder and we'll start building the fast API app right here. All right, so I'll just create a new file here, which is named main.py, just like Flask API. And we're gonna make a file inside this main.py. So for the requirements, we just need two requirements for now, which is first of all fast API, of course. So we're gonna install that using pip install fast API. And we're also gonna need to install uvicorn. So uvicorn is used to run fast API. So we're gonna install that. It is the ASGI server that will run our app. So to install uvicorn, you can run the command pip install uvicorn. So this will install uvicorn inside our system. All right, so for running a fast API, the simple syntax is uvicorn and then main semicolon and the name of the app which we are going to declare inside our file. So I'll show you how does that work. So first of all, I'm going to import fast API. So I'm going to use the command from fast API import fast API. All right, so once we get the fast API here, then we can start working with the actual code. So for the first app, we're going to declare the app inside a fast API, which is going to be just a fast API instance. All right, so now we can declare our routes for the app. So I'm just going to declare one route for this purpose because this is just a demo fast API and we're just going to learn how it works. So I'm going to declare the root index, the root URL, which is just going to be the slash, and then we're going to after writing the decorator as @app.get, and in the brackets the URL string, which is going to be just a simple slash. Then we can define a function. You can name it anything. I'll just name it read route, and then we're going to return an object. So for now, I'll just return a JSON object here, which can be something like hello world. So this is going to return just a JSON dictionary, which is of a dictionary type, and it will display it on the server, on the web page. All right, so let's see how does that work. And now we can simply run our applications. For running the application, we can run the command uvicorn main, which is the name of our file, semicolon, and then now the name of the fast API instance, which is the app instance. So by running this command, our fast API should boot up. Perfect. So as you can see, it is live on the port 8000, similar to the port 8000 for a Django application. Now, one more thing, if you want to configure a setting in which the application reloads itself on every time you make a change inside your file, so you can also put a reload flag against the command of uvicorn, and this will create your fast API and also reload it every time you change the file contents of main.py or any kind of py file you are building with this fast API. All right, so now I'll run this command, and as you can see, it is running on a 8000 port. So I'll just check it out. And as you can see, we have got the message of hello world. So that means our fast API is running perfectly. And that is basically how you can start working with fast API and build your first API using fast API. Hi guys, welcome back to the channel, and today we're going to learn how we can build dynamic endpoints using path and query parameters the right way. Alright, so in the previous video we have already built a simple fast API. We have already built the first fast API. This is a sample fast API which just returns hello world as a JSON format. So today we're going to learn how we can build dynamic URLs and dynamic endpoints, and we're going to learn how to use path parameters in those. All right, so let's begin. So this is a sample Fast API, we have built that day. So now we're going to build another URL here, URL endpoint here, which will include dynamic endpoints. So let's begin. So first of all, I'm going to name a root something like app.get, and then I can name something like maybe something like items slash, and then if I want to add a dynamic field here, then I can pass that inside the curly braces. So I'm going to use curly braces, and then I'm going to pass something like item ID or any other dynamic field you want to add. All right. So now I can define the root for this. So I'm going to define the root something like the function root something like define item, read item. And in this, I'm going to pass the dynamic variable which I had used in the URL. So this is going to be item ID. And what I can also pass is the type of variable that it is going to be. So it is going to be an integer. So I can pass the int type here. Perfect. And now we can simply define our root. So we can return the item. So for the returning the item, I'll just return it for now as item ID. And then I can return the actual item ID here. All right. So what does this format do is in FastAPI, it is actually dependent on the parameter type. The URL is dependent on the parameter type. So if I accidentally enter a string inside the item ID, it is going to throw me an error 422 error, which will declare that the type of parameter is not matching to the type of parameter required. So this actually allows for comparing the types of variables, which eventually makes the Fast API a lot faster than other Python web frameworks. All right, so now, and also one more thing, if you pass it even as a string of numbers, for example, if you pass something like a string of 7 or 8, it is going to convert to integer itself, so it will handle that procedure itself. So that is another great feature of Fast API. All right, perfect. So now that we have used item ID as a dynamic variable, now we can modify the root to add query parameter as well. So for the query parameter, I'm going to add it here after the item ID parameter here. So that is going to be Q, and that's going to be string, something like that. So that's going to work. Before that, I would like to show you how does this actually work with the item ID parameter. So for that, we'll just run this application. For running this application, you can run unicorn main app and the reload command as well. So I'm going to reach this directory. All right. I'm going to reach out to this URL slash, and then I'm going to go for items, and then I'm going to write in a number. All right, guys. So I just forgot to add a slash, preceding slash in front of the URL endpoint. So I'm just going to add that, and it should work perfectly fine now. All right. All right. So now if I reload my item slash one, it should return me item ID as one. Perfect. And now if I pass a string, something like hello, then it should give me an error. Yeah, perfect. So it gives me an error that is type in parsing. So it could not parse the input variable, the hello variable. So it has given us an error for that. All right, perfect. So now we'll move forward to the next part, which is actually using a query parameter inside this URL endpoint. So for using query parameter in this, we're going to put another parameter inside this, and that is going to be Q, which is going to be a string. And this initial, the default value for this can be none. So even if we do not pass this query parameter inside the URL, it is not going to affect that. All right. And now for the returning dictionary, we can add along with item ID, the query we passed through this. So I'm going to write query, and then that's going to be Q. All right. So this is how you can add query parameter inside your Fast API. Now let's test if how it works. If I go here and then I click on hello. If I click on 3, all right, so add a query parameter. Using a query parameter inside the URL, you can write a question mark here and then write in the query for your URL endpoint. It's going to be Q equals to something like swamp query. I'm just going to write query here, and this should return us the values item ID is 3 and query equals to query. Perfect. So that's how you can use query parameters inside your Fast API. That's great. Now moving forward, we can also embed the optional typed query inside these. So how to embed them is we're going to use a optional type query here. So suppose I have another root here, which is something like app.items, or maybe I'll just name it to products. And for this, I'm going to define the function as something like list products. And then here I can define my variables with a default value. For example, I'm going to use skip. That's going to be int equals to 0. So the default value for skip is going to be 0. And then I can also define some other variable which can be limit. And for this, I can have the default value as 10. Perfect. And now returning these values, we'll see how does this function for the FastAPI. All right, so for this, I'm going to run first of all the product. So, all right, just a little problem. I just forgot to add the app.get. And now we'll run this again. All right, so as we can see, we have got the default values for skip and limit, which were 0 and 10. And now if I want to change any of the parameters, I can change that using question mark. Skip equals to 9. So this should return the value of skip as 9 and the limit as the default value of 10. And now if I want to change the value of limit as well, I can use an AND operator here and then write in the value of limit as well, which is equals to something like 1. And this should return us the values of skip as 9 and limit as 1. So that's how you can use optional queries inside a parameter of the URL endpoint for FastAPI. Alright guys, so we have learned more basics of FastAPI, and in further videos we'll even deep dive into more advanced concepts for FastAPI. Hi guys, welcome back to the channel, and today we are deep diving into post requests and learning how to send and validate data in your API using Pydantic models. Alright, so this is how you build real-world API. So let's jump into the code. Alright, so first of all, I'm going to create a new file here just to save the previous code. So I'm going to name it something like main2.py. Alright. So first of all, we're going to import the Pydantic model. So what does Pydantic model does is basically it is used for building models or classes for the input type of our requests. So it can be easier to validate and verify the data for the endpoint. So basically it is used to create classes for input type parameters inside the URL. All right, so let's see how it works. So first of all, we can import the FastAPI from FastAPI. And after that, we can also import the Pydantic base model. So from Pydantic, we can import the base model. All right, perfect. Now we can define our app, which is going to be FastAPI. Perfect. Now we can define a Pydantic class. So we now will create a simple data model for an item. So I'm just going to name the class as item, and then we can define some parameters for this. So first of all, I can define some name, price, and isOffer, which is a bool value, and I'm going to set its default value to false. So this is a basic class. I'm going to use it as an input for my URL endpoint. So this is basically an item class, and now we can define the post endpoint. So for defining the post endpoint, we can use app.post, and I'm going to post that to the items URL. So now I can create my URL endpoint function, which is going to be something like define create item or something like you want. And the input is going to be item itself. So instead of passing each of these three as a parameter inside the query parameters, we are just passing the model name, which is the class name, which is the item class. All right, so moving forward, we can now, for testing purposes, we can simply return something like, first we can return a message, which is going to be item created or something like that. And then we can also return the item. All right, so now we can test this endpoint. How does it work? And how does our validation work as well? So I'm going to run this FastAPI using the uvcon command here, and it should be running on the 8000 port here. Perfect. So let's go to the 8000 port here, and these are my previous URLs. So first of all, if I go here, this is not even a URL endpoint, so it will not show up. So now I'm going to do what is I'm going to go to slash and I'm going to go to docs. So this is going to open the Swagger UI for my FastAPI. This is a simplified UI to basically run backend operations for your FastAPI running on your local host. All right, so how we can run how we can hit a post request using this is you can see we have got a URL here which is slash items. You can click on this and you can see it states all the details about this URL, how request body is configured with the name string, price 0, which is the default value, and is offer is false as default as well. All right, so now we can try this out. So for trying this out, we can click on try it out and I can pass a JSON body, JSON object for an item. So for the name, I can just pass something like name1. For the price, I'll just pass something like 100. And for the is offer, I'll just pass true for now. All right. So now if I execute this process, I should be able to see the item printed inside my console. So let's see if this works or not. Clicking on execute and we have the responses. So we have got the response code of 200, which means the item was created successfully. And we've also got the response body right here. So the response body says the message, which is item created, which we had embedded earlier. And we have also got the item, which is the exact item object we had passed in during the execution process here. Also inside our console, we can see that post request was hit here successfully. If I would have printed the item here, that would have also printed the item inside my console. So I'll just print that here itself and I will execute it again. And now if I see it here, okay, that was a little bit quicker. All right, so I can see the JSON object here, which is working perfectly fine. So that's how you can actually use Pydantic models to hit post request. So this basically eases the process of for FastAPI to compare and validate the item objects. So now one more thing we can do is we'll now pass a wrong parameter or a wrong JSON object of for item class. So I'm going to pass this removing the is offer variable from the JSON object, and now I'll execute this. And all right, so as you can see, I had not passed the is offer the is offer variable in this, and it did not matter because is offer is already set to false by itself, false by default. So that just picked up the value of false for it. But now if I pass in a string inside here, something like price is cheap, and then if I execute this should give me an error possibly. And yeah, so we can see the error code is 422 and it just says unprocessable entity. And it says JSON invalid, so that means the data validation has failed. And that's basically how FastAPI helps you to validate and verify the data, verify the request parameters quickly, and also make the API much, much faster than other frameworks. And guys, so that's how you can actually use post request and with Pydantic models. Hi guys, welcome back to the channel, and in this video you'll learn how to clean up your API responses using response models in FastAPI. Alright, so let's move forward with the process. So in the previous video we have used the base model from Pydantic to actually set up our input parameters for a URL endpoint. And in this video, we're going for the returning model, which is this item model, we're going to change it to something modified. So we're going to customize our response model using Pydantic maze model itself. So this is used for generally preventing some of the fields from transferring to the response, something like passwords or any secret variables other than that. Alright, so we'll see how you can use a response model for this. So I've already set up a post URL here, which is slash items, which just takes the input as this item model, which has three fields: the name, price, and is offer bool, which is the default value as false. Apart from this, from the create item, when the post request is hit, it just returns the message, which is the item created, and the item itself, which is the item model here only. All right, so now what we're going to do is we are going to suppose I'm going to add a variable, something like password, and this is going to be a string, and I just don't want to show this, so I'm just going to write don't show this. So this should supposedly not be visible inside the response of our post request. But when I run this app, it is visible, right? Let's just test it out. And if I run, now I have to give in the password itself, but Since it has a default value, I can skip giving a value here and I will just execute it here. All right. One more thing, just removing that. 100. All right, so as you can see, we have got the response, which has the item object here, stating the name, price, is offer, and password variables inside the model itself. So now what I want is I do not want this whole model items inside my response. I do not want to display the password. Apart from password, you can display everything, including name, prices, offer, but I don't want to display the password here. So how do we do that? Is we have to build a separate model for a response. So how do we build that? Is I'm going to build another model from the base model itself. So that's going to be something like class response model. We can have it as something like item response. And this is also extracted from the base model from Pydantic itself. And this is going to have the fields name, price, and we have the is offer itself, which is going to be bool, and the default value is going to be false. So this is going to be the default response model fields, and I will exclude the password here because I do not want to show that inside my response item. Perfect. And now how do I use this response model for my URL endpoint is just simply adding a field, adding a parameter after the app.post decorator, and I'm just going to add it something like response model, and this is equals to item response. All right, so the item response, the URL response, the post request response is going to be of the format type item response. We just have 3 fields out of the 4 original field inside the input item model. That's great. So now let's just test it out. How does this work? So I'll just go to the Swagger UI and I'll refresh this here. All right, so now I'll pass in the parameters for my URL. So I'll just click on try it out here, and I'm going to pass for the password. I'll just keep it something like password, and for the is offer, it's false. So this is my item object, which I'm going to pass in here. I'll just change this to true, and I'll just change it to 10. All right, so I'm going to pass it there in the URL, and let's see what response do we get. Alright, so one more change, guys. Since we are using a response model now, we cannot use the message here because this violates the rule of response model. If we want to use the message itself, we need to embed that in the item response model itself by the name of some field like message. But for now, I'll just skip it and I'll just return the item itself. So how do I return the item? I'll just return the item variable. That's it. So for this, I'll just do this, and now I'll test this API out. So let's see how does this work, and now I'll execute this. All right, so as you can see, we have got the 200 code here, which says the response body is name, price, and is offer. And as you can see, we did not get the password field inside the response. So that has been hidden now. And that's how you can actually use response model to modify the output response from an API. So this also makes your API endpoint secure and avoid leaking things like password, internal IDs, etc. And response models also help you to clean up messy responses, hide sensitive or irrelevant fields, and also create consistent and documented API endpoints. So guys, that's how you can use response models in API. Hi guys, welcome back to the channel, and today we're going to learn how we can connect our FastAPI to an SQL database. So for this SQL database, we're going to create it locally on a device in a .db file. But later on in the later videos, we'll learn how we can connect it to real databases online. All right, so let's begin. So for this process, we're going to use the SQL database in the .db file. So for that, I'll just create a new file here first of all for this tutorial. So I'll just name it something like main3.py. All right, and for this, you need to install a requirement which is called SQL model. So we'll just install that using pip, and that can be installed by pip install SQL model. All right, so after installing that requirement, we can start the coding process. So first of all, we're going to import SQL model from the SQL model library itself. So I'm going to import, first of all, SQL model, and then I'm going to import field for creating fields inside my model. After that, I'm going to import optional from the typing library, and I'm going to import optional from that. Apart from that, I'm also going to import from context lib, and we're going to import async context manager to run. This is basically used for running a command when the FastAPI is startup. So we'll just see how it actually runs. So I'll just import it for now, which is imported by async context manager. All right. So now we'll move forward to defining our models for our database. So first of all, I can define the model or class as the class item. And this is going to be the type of SQL model where the table parameter is going to be true because this is eventually going to be a table inside our database. So next we can define the fields inside our model or class. So the first field I'm going to keep is obviously ID, and this is first of all optional because eventually this is going to be an auto incremental field. So optional, and then we can set it to int optional, and then the default value for this is going to be field type for default equals to none. And by setting it as primary key, this is going to be a unique variable inside our table. All right, so let's move forward. I can define another field, something like name, which is string. Then I can define price for as a float variable. And I can also define is offer or any other variable you want. And I'll just set it as bool with the default value as false. All right. So moving forward, now we can set up our database files. So for that, we can first of all import from SQL model. We're going to import create engine and session. Now we're going to do what is, first of all, I'm going to define my SQLite file name, which is going to be database.db. Then we're going to define the SQLite URL, which is going to be SQLite semicolon /// and then the SQLite file name. All right, moving forward, now we can define the engine. So engine is created by the create engine method of SQL model. And for that, we're going to have the link of our SQLite database file and then echo equals to true. All right, moving forward, now we can write a function which just create the DB and tables. So for writing this function, we can do what is execute the command in the SQL model class, and then we will access the metadata class from that, and then we will use the create all function and create all the databases inside the engine which we are creating above. All right, so moving forward, now what we can do is, first of all, we can import from FastAPI, then we can import the FastAPI from that, and now we can create an instance of our app. There's going to be app equals to FastAPI. Now moving forward, now what we can do is now we can set up a function which will run every time our FastAPI is booted up. So what we're going to do is, first of all, we're going to run the create DB and tables function, which we created here whenever our FastAPI boots up. So for that, we can use async context manager, async context manager, and then we can define an async function, which is referred to as lifespan. And the argument for this is going to be the app, which is the FastAPI app for this. All right, so throughout the lifespan of this app, what happens on startup is we create the DB and tables, then we yield, and on shutdown, we do not have any command, so we just leave it as it is. So this is what a lifespan function does along with async context manager. All right, moving forward, what we can do is now import another thing, which is import depends from FastAPI. And now we can move forward defining our routes for our application. So for the routes, I can first of all define app.post. So first of all, we're going to define the posts route. So for that, I'm going to define it on the /items itself. And now I can define the function name, which can be something like create item. And in the arguments, I'm going to pass the item object. All right, moving forward, now we can refer to a session. So with session of the engine we have connected before, as session, what we're going to do is session.add item, and then we're going to commit that using session.commit. After that, we can refresh our session with the session.refresh with the item, and then we can return the item. All right, so this is how our post endpoint will run. After that, what we can do is we can actually first of all import list from typing library. And after that, we can also import select from the SQL model library. All right, this is used for reading the database data. So now I'm going to define the get endpoint of our items URL. So for this, I'm going to do app.get/items, and the response model is going to be list of the items. So the response will be returned in a list format of the item model. So now I'm going to define the function for our endpoint, and that's going to be read items. And we can move forward with session engine as session. Then we can have items equal to session.execute, and then we can execute this statement, which is select item.all. So for this, what we get is all the items in the section, and then we're going to return these items, and this will basically return all the items, and we'll be able to see all the items. So now let's test it out. So I'm going to run this application using the unicorn main3 semicolon app reload, and let's test it out now. All right, so I'm on my 8000 port, and now I'll just go to the docs to get my Swagger GUI. And in the Swagger UI, you can see two endpoints, which are get and post. So first of all, we're going to post it. So as you can see, we do not have a database. We did not have a database here. So if I hit a post request, I should be able to build a database now. So let's try to hit a post request. I'll click on try it out. And for now, I'll just hit it as it is. All right, guys. So as you can see, after hitting the post request, I've got a 200 code right here, which means everything is all right. And the response body is just the item object. So if I try to fetch the get items URL now, I should be able to see, yeah, so I can see all the items, which is just a single item right now. And now if I move forward by again posting to this URL, I should get an error probably because, yeah, internal server error, because I'm trying to push something again on the ID 0, which is a unique value. And for this, I also get the error unique constraint failed item.id. So if I change the ID now to 1 or something else, and then execute the statement, now I see that the function has executed that. And if I again use the get request, I see two objects now inside my database. So that's how you can handle SQL queries and database with FastAPI. Hi guys, welcome back to the channel, and today I'm going to show you how you can connect a PostgreSQL database with your FastAPI. So let's begin. So in the last video, we saw how we can connect SQL database locally on our FastAPI by using a database.db, basically a .db type file. But today we're going to connect our FastAPI to an online PostgreSQL database. So for this, I'm going to use Supabase, which is an open source PostgreSQL database provider. So for this, I have Supabase here, and I'll just show you the GUI for this right now. So this is basically how your project is set up. If you want to create a new project, you can, so this is basically the home screen, and for creating a new project, you can click on new project here, and then select the organization, and then select all other configuration here. And now you can fill in the details like project name and database password, and by clicking on create new project, your database will be created. So for my testing purposes, I've created a test named database here, and for connecting to this database, I can just click on connect right here, and you'll get the connection URI from here itself. There are 2 to 3 connection URIs provided, so you can use any of these. So I'll just use this, and I'll copy this and just paste it right here. First of all, I'll create a new file because this is a new tutorial, so I'm going to use a new file here, and this is going to be our connection URI. For the password, we can go inside the project settings, then we can go inside the database and click on reset database password. If you do not remember a password, I do not, so I'll just copy it here and reset the password. So this is going to be the password, and I can replace the your password placeholder with the password itself. So this is going to be our connection URI. I'll just save this in a variable right here. All right, so now we can move forward with the coding process. So first of all, we have to install some requirements for connecting to PostgreSQL database, which is psychopg2 binary, one of the install requirements. We're going to install that. And you also need to install the SQL model library as well, like we installed in during the SQL connection also. So the library is named SQL model. After connecting this, we can move forward with the coding process. All right, so first of all, I'm going to import SQL model. So for that, I will just import from SQL model, import SQL model, and then the field. And from the typing, we're going to import optional for making a field optional inside our database. Now I'm going to define the class of our models inside a database. So first class is going to be item. And for the item, I'm just going to make a standard database, which is going to be a SQL model instance with the table equals to true parameter, and then the ID is going to be optional integer with the field of default none and primary key equals to true. These are the field parameters. The name is going to be string, price is going to be float, and is offer is going to be bool. All right. So moving forward, now we can define another. Now we can import create engine from SQL model and the session as well. So now we will for the connection URI I have here, I'll just rename this to Postgres URI, and now we can create an engine using engine equals to create engine Postgres URI echo equals to true. So that will create an engine instance for your connection. So now I'm going to import from FastAPI. I'm going to import FastAPI, and now I'm going to import async context manager from context lib. So that's going to be context lib, and async context manager is basically used to run some function on startup or shutdown of your fast API. So I'm going to use this for running the creating database function on startup of our application. All right, so now I'm going to define a function for that, which is create DB and tables, and that is going to be SQL model.metadata.create all engine. So that is going to create all the models present inside your file, which is class item here, one of the models. Then moving forward, now we can define the async context manager, and then we can define the lifespan of our fast API, which is going to be something like create database and tables. Then we're going to yield, and that's it. We do not need to drop those, so we can move forward. Now what we can do is we can define our application, which is the fast API application, with the lifespan equals to lifespan variable, which is lifespan function, which is this. Then moving forward, we can also import the session from SQL model. So we had already imported that, so that's great here. So now we can do what? Now we can start defining our endpoints. So first of all, we're going to define app.post. For the app.post, we're going to keep the URL as items itself, and then we will create a function, something like define create item with the parameter as item model. And now for executing the database queries, we'll need to integrate a session. So with session of engine as session, then we're going to run the commands session.add, session.commit, and session.refresh. And then I'm going to return the item at last. All right, moving forward, now I can also import list from typing and also select from SQL model for making a read URL. So this is going to be a get URL. So for this, I'm going to define it as app.get items. The response for it is going to be the list of my item model. So for the read items function, I'm going to define with session engine as in session. The items are going to be session.execute select item.all. So this is going to select all the items inside my item table. All right, so that's perfect. And we have successfully made our whole API, a whole file. And now if we run this file using uvicorn main for app and reload. All right, so as you can see, our application is now booted up, and it says some logs from the database connection string or database connection functions. If the database or table is not present inside a database, then you should be able to see something like creating database or create table command of SQL. But the table was already inside my database, so it did not show this time. All right, so now if I try to access this API using my 8000 port /docs, I should be able to see two URLs. Yes, we can see get and post. So first of all, I'm going to post. So first of all, I'll just show you where exactly our database is located. So if I go into SQL editor, or if I go to table editor, I should be able to see our table named item. Yeah, perfect. So we see that. Now moving forward, we can hit a post request to this. For the post request, I'm just going to keep the parameter as it is. So first I'm going to click on try it out, and then the parameter as it is. Now I'm going to execute this, and we get a 200 code. That means it was successful. So now I'm going to see here if the data is stored or not. And now I'll just click on refresh here, and I should be able to see an entry right here. All right, so as you can see, I have the same entry which I had posted there with 0, string, 0, and false, which were the parameters I had posted right here. Now if I click on get and try it out, the get endpoint, it should return me a list of all the data, all the objects inside my database, which it does right here. Perfect. So that's how we can actually use PostgreSQL with FastAPI and connect it using the PostgreSQL connector. Hi guys, welcome back to the channel, and today I'm going to show you how you can connect your MySQL server to your FastAPI. So let's begin. So in the previous video, we discussed about how you can connect PostgreSQL server to our FastAPI. Now we're going to connect the MySQL server. So for the MySQL server, I've got a free server from freesqldatabase.com, and you can also get that get a free server from here. So my credentials for my server are these. So I'm going to connect to this database using FastAPI now, and then we're going to run some CRUD operations on that database. So let's begin. So for the MySQL URI, this is the standard format for connecting to a MySQL database. This goes something like MySQL plus PyMySQL semicolon slash slash, and this is the name of your host or the username. This is actually your database name, the database name semicolon, and this is the password for your application for your server. And then we have the host name, which is this, then the port name, and this is the username. So that is how the format looks like for a URI string. All right, so let's move forward. So now we'll start the coding process and how we can connect to this database, to this online database using our FastAPI. First of all, you need to install some requirements. So first of all, obviously you need to have FastAPI and UVcorn installed to run FastAPI. And also you need to install PyMySQL to be able to connect to an online SQL server. All right, after you install that, let's begin the coding part. So first of all, I can simply import FastAPI from the FastAPI module. And then we can also import the SQL model and field uh, functions from the SQL model library. Then we can also, and yeah, one more thing, you also need to install pip install SQL model because that's what is required to declare models inside our FastAPI. Moving forward, we can also import create engine and session from SQL model itself. And now we're going to import some more utility functions from typing class, from typing module. So that's going to be optional and list. All right. And we also have to import select from SQL model, which would be used to run select queries. One more thing, we can also import async context manager. This is used for running, for basically running the startup or shutdown commands when your FastAPI boots up. So basically every time your FastAPI boots up, we're going to run the command the create database, which will actually create the database inside your, inside this file on the online server of our MySQL database. All right, so let's move forward. So now I'm going to declare an engine here. So engine is going to be create engine and MySQL URL, and we're going to set the echo equals to true. Now we can declare our class, which is basically the model or the table present inside, which is going to be inside the SQL database. So that's going to be a standard database class or table. So I'm just going to have one field as ID. This is going to be an optional because it is eventually going to be auto incremental and primary key. Then you can have name, which is as the string, price as float, its offer is bool with the default value as false. All right, moving forward, we can now define a function which will create the database. So that's going to be something like SQL model.metadata.create all an engine. This will detect all the tables or the classes inside a file, and then it will create the tables from them for them accordingly on the SQL server online. And now I'm going to use the async context manager for basically running this function every time our application boots up. So this is going to be an async function which is defined as lifespan, and it takes the argument as the app instance we had created for our FastAPI, which we are going to create later on. And also the create DB and tables function is called at the startup. After the yield, you can write the shutdown function, but we do not have any shutdown function for now, so we can skip for that. Now we can declare the app, which is going to be FastAPI with the lifespan parameter as the lifespan function we have declared above. All right, so now we can move on to building our endpoints for our FastAPI. So first of all, I'm going to create a post endpoint, which is going to be app.postItems. There's a simple uh, endpoint for posting to the FastAPI, and this is going to be a define create item function, which will take the input as the item object we have defined earlier, and that is going to just run with the session.engine as session, and then it is going to run the following commands, which is going to be session.add the item to the database, and then committing the a query, and then refreshing the item to our database, and then we're going to return the item as a response. Now we can simply write another get endpoint for this FastAPI. So for this, we can write the app.get/items itself. And for the response model, which will be the response format of this API endpoint, which is going to be the list of the item model we have defined above. So it is going to return a list of items. All right. So we're going to define read items here. So with this, now the query for this is going to be with session engine as session. Obviously, first we need to declare a session here, and then the item is going to be session.execute. And this is the command basically. So this is the command select item and dot all. So we're going to select all the items from the item table. So this is going to, and then return it as a response here. All right, perfect. So I think this should be enough for us to basically build this API, and let's just test it out now. So for running this, we can run the command uvicorn main5 semicolon app reload, and then running this. All right, so as you can see, it has printed some logs related to SQL database. And there's this command you can see which says create table item. So basically, whenever our FastAPI boots up, it tries to create or find the table item here. So it has created this for the first time because I've booted this for the first time. So it has created the table named item. Perfect, and it is running completely. So application startup is complete. So now we can basically start hitting requests to this. So for now, I can go to the local port 8000/docs for getting the this is basically called the Swagger UI for FastAPI, as you can see above. So now we can see the two endpoints we have declared, which is the get and post for items. So first of all, I'm going to post some items here to the database. So I'm going to use try it out, and then this is going to be one of the statements. I will execute it. All right. So guys, as you can see, the query has been run successfully, and it has returned the response body, which is just the item object itself. So that means it should successfully have transferred the data to our database as well. So I'll just check my GET request now and see if the data comes or not. Yes, there it is. Now I'll post the request once more just to test another string, another data entry. So for the name, I can just choose any name. For the price, I'll just take 10. And this time I'll keep it as true. And now I'll execute this query. So this again returned a 200 code and also a response here. And now I'll again run the get query here. And now I see two entries of our data inside our database. And for proof, I have opened the PHP my admin right here for my database online. So I'll just refresh it and see if the fields are populated or not. All right, so as you can see, I've got two fields here, ID1 and 2, which are the corresponding fields I had entered inside the post request at my /items endpoint. So perfect. That means our app is working perfectly fine. And that's how you can actually connect MySQL server to your FastAPI in few simple steps. Hi guys, welcome back to the channel. And today I'm going to show you how you can set up a user authentication system using FastAPI. So we're going to use a user auth simple basic user auth system. We're going to have the functionality of logging in and then signing up also. And also we're going to use the hashed password for storing inside a database. So let's begin how we can do that. Alright, so first of all, we have to install some requirements. So for the requirements, we can um, open up our terminal here. And here we can install some requirements. So for the requirements, we have something like, first of all, we can obviously install the FastAPI. Apart from that, we can also install Uvicorn and SQL Alchemy, and then Parslib, bcrypt, and also databases. So let me just show you how it works. So first of all, I'm gonna enter inside my directory. First of all, I'll just activate my virtual environment. And now I can enter inside my directory, and now I can install the requirements. So first of all, I can install FastAPI, then Uvicorn, SQL Alchemy, because I'm going to use an SQL database here. So if you're using PostgreSQL, you can install psychopg2 binary for that. But here I'm using an SQL library or an SQL table. So let's begin. Apart from SQL Alchemy, we can have parslib, bcrypt. This is the library which will be used for hashing the password. And after bcrypt, we can also install databases for getting some easy database functions. All right. So after installing all of these libraries, we can move forward to the next part. So first of all, what we're going to do is first of all, we're going to make our database file. So for that, I have opened a db.py named file right here. So I'm going to show you what all we're going to write in this. So, all right, so my requirements have been installed. Now we can move forward to the coding part. All right, so first of all, I'm going to I'm going to import SQL cut. I'm going to import SQL Alchemy's engine. So for that, you can import create engine. Then you can also import something like let's just use create engine in the main file. For now, we can import the table, column, and integer for my integer fields, string for my string fields. All right, so that's all. And from the databases, we can install some functions like metadata, which is going to give us the data about the table itself. All right, so now I can define a table here. So the users table is going to be the table we're going to use. So that's going to be a table instance. And the parameters are going to be, first of all, the name of the tables, which can be users itself. Then you can have the metadata parameter. And now I can start defining the columns. All right, so first of all, I'm going to have the column of ID here. Then we're going to have the column of username, which is going to be a string, and unique and nullable as well. Nullable is going to be false because it cannot be null actually, because it is a unique username eventually. And also we're going to allow the indexing, because this is we're going to use to look up for user entries frequently. So we can enable indexing, which will allow us to search through the username column quickly. Then we can have a column for password, and this is going to be just a string. All right. So this is going to be our database. So let's just save this file and move on to the next file. So the next file is going to be something like models.py. There's a small change. Actually, this file belongs to the models.py itself because we have defined the model here. So for the db.py, now I'm going to show you what basically we have to configure our database inside this. So for this, first of all, you can import the SQL engine here. So for importing SQL engine, you can import create engine from SQL Alchemy, and then you can also import metadata here. All right. For the metadata, we can move forward for importing database from database library. I can import a database from here, so we can later refer to this. All right, and now I can basically start configuring my database. So for this, first of all, I'm going to define my database URL or URI. If you're using an online database, you can have the connection string from there itself, but I'm going to use a local database here, so I'm just going to define it like an SQLite database here. So this is going to be named as users actually. And then we can move forward by defining the database instance. So that's going to be database equals to database of database URL. Then I'm going to have the engine, which is going to be, first of all, we can also define the metadata, and we can have the engine here itself. So for the engine, we can remove these extra arguments. It's okay. We can just have an engine of the database URL instance. That's it. So this is our database.py file, and now we can move on to the next part. So now we can define the schemas for our file. So the schemas are going to be basically the Pydantic models, which we're going to use as inputs for our endpoints. So we can make them in a separate file named as schemas.py. So from here, I'm going to I'm going to import from Pydantic import base model. All right. So just a second. All right. So importing base model. Now we can build our schema. So first of all, I'm going to build a user create schema, and then this is going to be an instance of base model itself, and it's going to have just two fields, which are username and password. So for creating the username, creating the user, we're going to use the user create uh, schema here, and for the user login, we're going to create another schema here just for the sake of segregation and heterogeneity. We can use that. For this case, both of them are exactly same, so we can eventually use the same inside our main application. But in some cases, you might have different for both. You might have different fields for both. For example, for the user create, you might also involve some other input categories like the email for the user or something like the phone number for the user. But for the user login, you might only need the username and password. So we have defined the user login according to that. So in this case, both are same because we are just keeping it as a simple system for now. Also, now we move on to the main file. So for the main file, I can name it something like app.py. Now we can start building our actual FastAPI. All right. So first of all, obviously we're going to import the FastAPI. So for that, you can use from FastAPI, import FastAPI, and then we can also import the HTTP exception for handling our exceptions. Now we're going to import the hashing function. So that's going to be from parslib.context import crypt context. All right. And from the database, we're going to import something else now. So I'm going to import database, import database, and metadata and engine. All right, so I'm going to import that using database, comma, This is actually going to be our db.py file. So that can be actually the db here, and we're going to import the database, engine, and metadata. From the models, we're going to import the users, and from schemas, we're going to import the user create and user login schemas. All right, perfect. So now we can move forward. So first of all, I'm going to define a FastAPI instance as app, and then I'm going to create my engines, create my tables. So for that, you can execute the function metadata.createAll engine that will create all the data for the tables inside our engine, which is connected to the database. Moving forward, now we can have PWD context, which is password context. So this is just a crypt context instance, which we used to hash our password. Moving forward, now we can first of all have a startup event, which is going to be app.onEvent startup. On the startup of our application, what we can do is connect to our database. So how we can do that is async define startup and then await database.connect. So this will await till the database is connected and then move forward with the other steps. Also, what we can do is on the shutdown of our fast API, we can disconnect from the database just to maintain uniformity. And so for that, you can use the function app.on event. And for the shutdown argument, we can use async define shutdown function, which will disconnect the database here. All right, so now we can finally start building our endpoints here. So first of all, what we're going to do is @app.post. So this is going to be a post endpoint, and we're going to have the slash register URL right here. So for this, I'm going to define async define register, and this is going to have the argument as the Pydantic model of user create, because this is eventually going to create the user. And for the query here, we have users dot insert value, which is going to be the username and the hashed password. So I'm just going to write it again for you. So we can have the query, which we're going to execute. This is going to be users dot. So first of all, what I'm going to do is I'm going to check if any users exist or not. If they do, then I'm going to give an error or something like that. So first of all, I'm going to do users dot select and then dot where. And now I'm going to put the condition, which is going to be users.c.username equals to user.username. So if that exists, now existing user is going to be database.fetch one query, which is going to be execute the query inside a database. And then if the existing user exists, then we can give him an exception that the username already exists, something like this, which is going to be an HTTP exception here. This is going to raise an status code 400, and the details are going to be username already exist. All right, so let's move forward. Now, if this condition surpasses, that means the username does not already exist, and now we shall focus on creating the user inside our database. So for that, first of all, we're going to have the hashed password here, which is going to be pwd context instance and the hash function for that. So that's going to be pwd context dot hash and then user dot password. So we're going to hash the password here, and then we can execute our query, which is going to be users dot inserts dot values, and the username is going to be user dot username, and the password is going to be hashed password. All right, and now I'm going to await for the database to execute this query here, and then I can just simply return a message, something like user registered successfully. All right, perfect. So this is our whole register endpoint, and now we can move forward to building our login endpoint. So for the login endpoint, we have here, and I'm going to define the async define login. And for this, I'm going to have the Pydantic model as user login. These are technically the same for me right now, but might be different for you when you build a real world application or when you build a complex application with a user having multiple attributes. All right. So moving forward, now we can define our function. So first of all, I'm going to define the query, which is going to be users.select.user, where the username is equals to user, and I'm going to check if the user exists or not. So for that, I'm going to access this query inside my database. And for now, if the user does not exist, then I think we should get an error that invalid username. So I'm going to post an error here, which is going to be invalid username or password, just to maintain ambiguity amongst the users, which will eventually increase the security. Now moving forward, if now the next step is we can verify the password of a user. So for that, what we can do is, if we got the user here, then what we're going to do is, if not pwd password, pwd context.verify, this function actually verifies the hashed password, and these two values are actually verifying itself, verifying themselves using the function. So if they are not verified, that means this is a wrong password. So I'm gonna raise an error here, which is invalid username or password again. And after that, if we are successfully passing through both of these if conditions, that means the username and password, both of them were correct. So now I can return a successful message here, which is something like return message login successful. All right, perfect. So we have developed our whole system here, and now I think we can run our FastAPI and see how it works in real life. So first, I'm going to run the app using UVcorn app semicolon app and hyphen reload flag. All right, so it has started up completely. So let's now visit the localhost 8000 port here. So I'm going to visit the port here, and all right, so I have a API right here. So I'm going to access this using my Swagger UI for FastAPI. And so as you can see, we have got two endpoints here, register and login. So first of all, we're going to test the registered endpoint if it's working or not. So I'm going to click on try it out here. So username is going to be something like admin, and the password is going to be something like pass, or I can just get it like ABC123, and now I can execute this query. All right, so as you can see, we have got the response as the code 200, which means it was successful, and also we've got the message as user registered successfully. Perfect. So now we can test it out if a user exists or not. So we can go to the login endpoint here and click on try it out. So first of all, I'm going to test it out if something else, something wrong works or not. So I'm going to test it out something like ABC12. So this is not our original password. So this should return us something like invalid username or password right here. Perfect. And for the username, I can change it something like this user, and this should also return us an invalid username or password. Perfect. So now I'm going to pass in the correct credentials here, and it should give us a success message right now. All right, so as you can see, we have got a response code 200, which says message as login successful. We have successfully implemented a login and logout user authentication system. Hi guys, welcome back to the channel, and in this video, we're going to see how we can implement a middleware inside our FastAPI. So middlewares are exactly the functions which run before hitting a request on our server. So we can actually have some conditions set up in our middleware before hitting the server, and that would verify the request according to that. So basically, it's a pre-check before a request is actually hit on our endpoint. All right, so let's begin. So in the last video, we learned about how we can authorize a user using a simple login and logout command, login and register commands. And so in this video, I'm going to make a middleware.py named file here, and I'm going to show you how you can implement a middleware right here. All right, so first of all, we are obviously going to import FastAPI. So we're going to have FastAPI here, and you can install the requirements using pip install FastAPI here. And also I'm going to have one more thing, which is going to be request this time. All right, moving forward, we can have import time. Just to implement a middleware. I'm going to show you what middleware I'm going to implement. And now I can start up my FastAPI instance here, and now I can start implementing the middleware. All right, so for implementing the middleware, you will need to explicitly specify here that app.middleware on the HTTP requests. All right, so this is going to implement our middleware on all HTTP requests. So for the app.middleware HTTP, now we can move forward as defining our middleware function. So this is going to be something like define. So what I'm going to do as a middleware is I'm going to log every request's time. So I'm going to print the time of every request. So that is basically going to check the request and then print the current time. And then that is basically what our middleware is going to do. You can have multiple conditions that something like verifying what the requests have and other things like that. But I'm just going to keep it as a simple middleware here. So I'm going to define it something like define. I'm going to log the request time here. So something like this. And then for the request, I'm going to have the request type of request here. So this is actually going to be the request which we are going to hit on our endpoint. Remember, this is not the actual endpoint. This is just a middleware. So we are defining it separately from our endpoints. We will define the endpoints after this. And then we're going to have another parameter which is call next. This is just a default parameter inside a middleware. All right, so now we can move forward. So first of all, I'm going to have the start time, which is going to be time.time. And then we can have something like response. So response is basically await call next of request. So the request next step is going to be response. So we are going to store that. Now we can move forward as process time. The process time is going to be something like time.time minus start time. So this is going to be the current time minus the start time. So response is basically going to be the thing the processing you're going to the processing our endpoint is going to take, and the process time is going to be the current time minus the start time of the request. And maybe now I can just print a simple statement, something like request.method or request.url or other things here, something basically to something print here, and then I can return our response. All right, so now I can do what? As I can define a simple endpoint here, just a get endpoint of the root URL, which is going to be define, read root, something like that. And then we're going to have something like hello world returning. And that is going to be our simple middleware implementation right here. So I'm just going to run this file right now, and I can run that using Unicorn. You can also install Unicorn using pip install Unicorn here. Unicorn middleware semicolon app, and I can implement the reload flag here. All right, so application startup has complete. So now I'm going to visit the local host here. So as you can see, I've got the hello world here, which is the GET request on the root server itself. So I'm going to see if the request got printed or not. As you can see, we have this exact string printed here with all of the parameters we wanted to actually hit it. So this is the request.url, which is the localhost, request.method, which is the get method, and the process time calculated right here, which is in some milliseconds. So that's how simple it is to actually implement middleware inside the FastAPI. Hi guys, welcome back to the channel, and today I'm going to show you how you can implement CRUD APIs inside a FastAPI. So let's begin. So I'm going to implement some basic CRUD APIs. We're going to implement the post method, the get method, the put method, and the delete method here. Alright, so how I'm going to implement it is it's just going to be a simple item CRUD function. So we're going to have some items, and we're going to have some item table, and then we're going to implement some CRUD functions on that table. All right, so let's begin. So first of all, I'm going to define the main file here. So for the main file, so before that, I can define my database file actually. And so for the database file, I can make another file here, which is going to be something like db2.py, because I've already made the db.py in the previous video. So from this, the first of all, I'm going to install some requirements. So first of all, I'm going to install the SQL Alchemy for connecting to my database, SQL Alchemy. Then I'm going to import something like databases, but we can skip that for now, and obviously the fast API and Unicorn as well. So I think that would be enough for this time. So let's begin. So for the database file, first of all, what we're going to have is first of all have the from SQL Alchemy command, and then what we're going to have here is import the create engine from there. Then what we're going to have is importing from SQL Alchemy. We're going to have something like declarative base, and then we're going to have session maker to basically build a session inside our database engine. So for the database URL, we're going to have it on our local system right here. I'm going to name it something like items.db. So this is going to be a local database of items on my device itself. But if you wish to connect it to an online database, you can also connect that using the connection string for that database online. All right, so now I'm going to define the engine here, which is going to be the create engine right here. All right, moving forward, we can have the base here now. So base is going to be the declarative base of this SQL table. Then we're going to have the session local here, which is going to be a session maker instance. The bind is referred to as engine. auto commit is false, and auto flush is also false. All right, so this is going to be our db2.py table right here, db2.py file right here, which is going to create an items table inside a database. So I already have an items.db here. I'm going to delete this here to avoid the conflicts between my databases. All right, so moving forward, now we can make our models file. So for that, we can build, make a file something like models2.py because I already have a models file before. And this is going to be a simple file, just having one table for item. So that from SQL Alchemy, we can import, not create engine this time, we have to import column, integer, string, and float for different types of fields inside our table. And we're also going to import uh, db2. From db2, what we're going to import is the base. All right, so now we can move forward by building our class, which is actually the database table here, the item table. So this is going to be a reference of base of our database engine. All right, moving forward. First of all, what I'm going to define is the table name parameter, which is going to be the items parameter here. And there are some extra fields here. So the fields are ID, which is a column of integer, the primary key, and also index equals to true for searching through IDs efficiently. Then we have name, which is a column of string itself again. And apart from that, I can remove the description here and have the price here and I have the quantity here. All right, simple. This is just a simple item table right here inside my database, which I'm going to create after my execution of this application. All right, so moving forward, now we can actually develop our application. So I'm going to name it something like CRUD.py for now. So for CRUD.py, we can start building our FastAPI here. From FastAPI, import FastAPI. Then we're going to import Pydantic models for basically referencing to our model input type for the request. So that's going to be from Pydantic import base model. Now from db2, what we're going to import is, first of all, we're going to import engine. Then we're going to import the session of our engine as well. All right. From the models, what we're going to import is the base and the item model. All right, perfect. So this is perfect. Now we can move forward and define our FastAPI instance right here. Apart from that, what we're going to do is now base dot metadata dot create all engine bind equals to engine. This is going to create all the tables inside our database and models file inside our database itself. All right, so now moving forward, now we can define a Pydantic model here. So that is going to be something like item schema. So the item schema is a reference of base model with three inputs, which are name, description, and price. Name, price, and quantity. Actually, I'm sorry for that. So the quantity is going to be an int. So as you can see, in the model, we had four values actually, which is ID, name, price, and quantity. But ID is actually a primary key, so we do not need to pass in through our request, which we're going to hit through the API endpoint. All right, so now we can move forward and define our post method, the post endpoint of our application, which is going to be the items endpoint right here. And this is going to be, and now I can define the function here, which is going to be something like define create item. Then the input is going to be the Pydantic model of item schema. The DB is going to be the session DB, which we had started earlier. And then we can have the DB item equals to item of name equals to item dot name, quantity equals to item dot quantity, and the price equals to item dot price. So this is going to be a DB item, which is an object of the which is an object of the class item. So that is basically what we're gonna implement here. And then we can db execute the command, which is db.add db item, and then db.commit and refresh that item inside our database, and then just close the database and then returning the new items. So this is our basic post request here. And now we're gonna handle a basic get request. So for the get request, what we're going to do is have the app.get items slash item ID. So so we will get that item ID using this get function. So for this, we're going to implement a function, which is going to be define get item. And this function will have two input. We'll have just one input, which is going to be item ID. And that's going to be int, which is going to be extracted from the URL itself here. So this will not require any Pydantic models because we do not need to actually post a request, or basically we do not need any extra data accept the item ID here. So that is going to be a simple API call right here, which is going to be get items slash item ID API call. So for the DB, I'm going to define it as session local. So we are basically running a local session of DB here, which is going to be which is going to be used in all the endpoints here. So that makes the process a little bit easier. And the item is going to be db.query. So we're going to execute a query inside our item model here now. So this query is going to be dot filter all of the items, and the item filtered are going to be item dot id is equals to the item id parameter for our URL. Now we're going to have the first entry or first object from these. It is eventually going to be only one object because the item ID is a unique value. But just for the sake of security or something like that, we can move forward and now close the DB here. And now we can add check something like if not item, then we can raise some exception. So we can raise an exception here, or if you do not want to raise an exception, we can just return an error, which is item not found. And else, what we're going to do is just return the item because we have found the item inside our database. All right, perfect. So moving forward, now we can do now we can build an put endpoint. So for the put endpoint, what does a put endpoint do is basically modify a current entry inside a database. So for that, we also need to have the item ID as one of the parameters in the URL. So this is going to be labeled as app.put items slash item ID. So now I'm going to name our endpoint something like update item, and this is going to be the item ID, which is going to be the end. And for this, what we can do is we can actually get the item schema Pydantic model because eventually we need to take the input of whole item model inside this request, because eventually we're going to modify the model. So we need to have all the fields of the object as well. All right, so now I'm going to define the session local database here, and then we can have the DB item for the query as db.query item.filter item.id equals to item id dot first. So this is basically getting the first object inside the item table with that item ID. So if we do not have that item ID, we just simply return an error, which is item not found. But if we do have an item ID, then what we do is basically modify that item's parameters, basically that item's field. So that is db items name is now changed to item.name, which was our Pydantic input here. So similarly, quantity and price are also changed here. And then we commit that command and then refresh the database item here. Then we close the database and just return the database item here. Perfect. All right, so now we have done the put method also, and now we can do what? We can implement the delete request here, which is the last step of our CRUD operations, create, remove, which were create, read, update, and delete. So we are on the delete part right now. So for deleting also, we need to have an ID of our item. So for that, we need to also have item ID inside our endpoint name as well. And now I'm going to define the function as define delete item. And I'm just going to pass a single item ID as the input because that's all we need to delete that item. So first of all, I'm going to refer to our session local database here. And then moving forward, we're going to get that item from our database. So that's going to be db.query. From the item table, we're going to filter on the basis of item.id, which should be equal to our input ID itself. And we're going to get the first element of that. So the first case is if we do not get that item ID, what happens then? That simply means that it does not exist. All right, so I just started Python here for some reason. Let me just exit it. All right. And yeah, so if the DB item does not even exist, so that's just a simple red flag, and we can just close the DB here and just return some kind of error message right here, which is going to be a JSON for error and item not found, something like that. All right. Moving forward, what we can do in the else case is basically just simply execute our delete function because that is eventually what this endpoint does. So we're going to delete that DB item, and that's it. We have deleted the DB item, and now I can commit my database and also refresh. But in this case, I do not need to refresh because it is eventually deleted itself. So I'm going to close the database here. After closing, we can simply just return a success message, something like item deleted successfully. All right, perfect. So we have implemented all of the 4 CRUD operations for our item model here. And now we can test it out. So for testing out, I will first of all run this uh, FastAPI using Uvicorn. So this is going to be Uvicorn, and the name of our file is CRUD, and the name of the application inside our file is app itself, app, and then I'm going to enable the reload flag here. So one more thing, for the declarative base and session maker system, the settings, we actually have to import them using the SQL.orm instead of SQL Alchemy. All right, so now it should work perfect. So let's just wait for this to start up. And as you can see, application startup has completed. So let's now go to our browser and check out our FastAPI endpoints. All right, so I'll just go to the Swagger UI of our FastAPI here, which is going to be /docs. And as you can see, we have all the methods right here, which are post, get, put, and delete. So let's test it out, each one by one. So first of all, I'm going to test out a get method. So that should eventually return us nothing here. So let's just wait for that. So first of all, I'm going to create an item here. So for the post item, I'm going to try it out here. So I have 3 fields here, name, quantity, and price. So first of all, I'm going to name it something like sugar. And the quantity is 1. The price is something like 5, 4. And I'm going to execute this. And for this, I have this I've been returned with the response code 200, which means the item was created successfully, and I have been returned with the item itself. So as you can see, the ID for this item was 1. This actually increments automatically. So I'm just going to create another thing, which is going to be name as T, quantity I'm going to keep as 2, and the price is going to be 7. 7, and I'm going to execute this query now. All right, so as you can see, the ID has been all auto incremented to 2 here, and we have made 2 objects inside our database. Perfect. So let's move forward. Now we can hit our get request now. Click on try it out here, and for the item ID, first of all, I'm going to get my sugar item here, which is going to be here. Perfect. Then I'm going to get my tea, which is this. Perfect. And if I try to get some other thing, it should just give me an error here. Yeah. So it just gives me an error which says item not found. Perfect. So that is how actually my get endpoint was supposed to work. And now we can click on put. So let's just try the updation method here. So then we already have name, quantity, price here. So for the updation, I need to pass another parameter here, which is going to be ID. So for the ID, I can pass it here itself. So now I can change the name, quantity, and price according to that. So the name was sugar for this quantity. I can now shift the quantity to 5 now. And for the price, I can keep it 4 itself. So now I'll execute this query. And as you can see, we have got the response 200, which means that it was successful. And we have got the name as sugar, price 4, quantity has been increased to 5, and the ID is 1 itself. So now if I get this item here, which is to the 1, I should be able to get the quantity as 5. Perfect. So that means we have updated our sugar here. That's great. Now moving forward, now we can work with our delete API, delete endpoint here. So for the item ID, if I pass some random integer, I should get error item not found. Perfect. So this is actually the error because that ID does not even exist. So now I'll just pass in my ID1. So let's see what happens. All right. So it says message item deleted successfully. So that means item has been deleted. So if I again execute the 1 query, it says item not found, which means it is not present inside our database now. So if I again use the get endpoint to get that to get that item, I again get the error as error item not found. So that means our delete endpoint is working great as well. So perfect. So that's how basically our all 4 CRUD operations work inside our Fast API, and that's how you can basically write some CRUD APIs in Fast. Hi guys, welcome back to the channel, and I'm going to show you how you can work with Jinja templates and also form submission inside your Fast API. So let's begin. So for this video, I will make a simple form on my HTML page, and we're going to submit that form with some data like username and frequency, and then I'm going to basically append that username with that frequency inside the next HTML page. So let's work with Ginger, HTML, and form submission on FastAPI. All right. So for this, I have 2 HTML templates right here, which are index, first of all. So this is a basic HTML document. As you can see, this just have something like hello enter your name, and then we have a form here which submits to the endpoint /submit, which we will develop using FastAPI right now. So for the form, and the method is going to be post right here, and we have input. We have two inputs here, which are first of all text as username and the number as frequency. Then we just have a button which is of the type submit to submit the form. And for the result, we have another Ginger template here. So basically, Ginger templating does what is basically it lets us use coding logics inside an HTML document. So basically, as you can see, this is how Ginger works. So this Ginger is basically written inside the curly braces like this. So for the Ginger, what does it do? Basically, as you can see, we have implemented a for loop here. So for I in range frequency. So this is first of all implemented between these percentage signs, and also for I in range frequency, that means frequency is a variable. So this frequency comes from basically the context for the template, which we're going to see in few seconds. How does it work actually? So basically, frequency comes from the FastAPI, and the username variables come from the FastAPI itself. The I is basically the variable inside here, and that's basically how Ginger templating works, basically using dynamic variables inside dynamic variables, functions, and tags inside our HTML document. All right, so now let's develop it. So I'm going to I'm going to build a file inside my FastAPI, naming something like html.py, and let's begin developing our FastAPI. All right. So first of all, I'm going to import FastAPI from FastAPI, obviously, and then we can also have the request to actually handle the request, and also we're going to have a form to handle the form submission as well. Moving forward, we can have the HTML response from FastAPI.responses, and also we can have FastAPI templating system as Ginger2 templates imported from FastAPI.templating. We can also import from path library. We can also import path to basically refer to our path to our Ginger templates, which is basically the HTML templates. All right, so now we can begin declaring our FastAPI object right here, and now we can set up the templates folder first of all. So first of all, the base directory is going to be the directory of our project root right here, which is going to be path, and this is going to have the arguments as the file, which this currently is in, and we're going to resolve this path, and we're going to get the parent for this path, which is going to be the base of this directory. So what does this get basically is basically we are inside the FastAPI folder, as you can see. So this basically gets the path of the FastAPI folder on our system. So that is basically the base directory. So I think you guys can guess the templates directory is going to be the base directory, which is the FastAPI/templates. So that is exactly what is being done right here. Templates equals to Ginger2 templates, directory equals to base directory/templates, which is this template. So we have declared our templates directory here using Ginger2 templates object. All right, so now we can move forward on defining our endpoint. So first of all, we're going to have the root endpoint. And for this, we're going to have just a slash here. And for the response class, what we're going to have is the response class for this is not going to be JSON as default like we used to do it before, but an HTML response because we want to return a HTML template on getting this URL. All right, so moving forward, what we can do is now define our root function here, and the request is going to be the request itself. All right, so this is going to return. This is going to be just a simple return of template. So that's going to return the templates.template response. And the template response will have two arguments. First of all, it's going to have the name of the template, which is going to be in the index.html. Then it's going to have the context. So context is basically a dictionary of dynamic variables. So the context as request is basically have all the parameters regarding the request, like request.user or request.headers and request.body, or all the parameters of that request. Although we do not need to pass request to the context here, this is just to show you how does context inside templates work inside our FastAPI. All right, so now I can basically define a post function here, which will basically use to submit the form to this endpoint. So for the name, it can be just /submit because that's what we had declared inside our form right here. Let me just show you here. Yeah, so this is the /submit form right here. And for this, the response is again going to be the HTML response because we have to redirect it to a new page, which will basically show the username entered to that number of frequency times, which we will enter in the form again. So now we'll just see how we can disassociate the form variables inside our endpoint. So first of all, I'm going to have the URL named something like submit form. All right. So first of all, I'm going to have the request parameter. This is for default whenever you are working with response classes as HTML. Then moving forward, so first of all, if we see our index.html, we have input type text, name, username. So we have one name as username and another as which is frequency. So we need to get both these variables from our form. So how do we get that is, first of all, we're going to have the username here. For the username, what we're going to have is, this is going to be the string type, and we're going to get this from the form. So for getting it from the form, what we're going to do is just refer to the form object here, and we can get the 3 dots here. So this is going to be, this will just unpack the form values automatically and get the username from that. Similarly, we need to get the frequency variable from the form itself. So that's going to be an int variable, and we can also get it from the form object itself. All right, perfect. So that's how we will define our submit form endpoint function. And now we can just simply return the template, which is going to be result.html, and then I'm going to pass all these variables inside context. So as you can see, this is our context dictionary. I can explicitly define it above also, so I'll just do that. As you can see, we have got the context dictionary here, and I can pass the context here. All right, perfect. So in the result.html, as you can see, the FREQ is going to be this value, which we get from the form on our previous submission, and the username value is going to be the username we get from the form submission as well. So perfect. So that is, I think, should work perfectly. So let's now try it out. And for running this app, we can run the command unicorn HTML's app and then reload it again. All right, perfect. So let's head to our local host. And as you can see, we've got the hello, enter your name, and this should be the username field, and this should be the frequency field. So for the username field, I can add something like hello. And for the frequency, I'm going to display it in the loop for 5 times. So let's submit it now. All right. So as you can see, we have got hi, hello, 0, welcome to FastAPI and HTML. So we have got the username value here and the is value here, which was actually the I in range function. So I'll just show you here. Hi, username, and then we get the I, which was the value of range frequency, and then we have welcome to FastAPI, and we have a go back URL as well inside the loop. So as you can see, we have got the number of frequency times the format we had set up inside our result.html document. Alright, so that's how you can basically handle form submissions and also Ginger templating inside your FastAPI applications. Hi guys, welcome back to the channel, and today I'm going to show you how you can use configuration file and environment variables inside your FastAPI. So let's get straight to the video. So I'm going to make an app.py file or an application file inside my FastAPI folder right here. I'm going to name it something like um, environment or something like environ.py, and we can start working with our application. All right, so this is going to be a very simple application right now. So what I'm going to do is, first of all, I will define some configurations for my uh, file itself. So I'm going to name it something like conf file. So that's going to be conf.py. And for the configuration file, I will just now configure my actual configurations here. Before that, I can also define my environment file. So I already have an environment file right here, which have my 2 secret variables. So these are very secret variables, should not be showed publicly to anybody, but it is stored inside a .env file here. So the first variable is database URL, which is just the local users database, and then I have a secret key here, which is something like super secret key 123. So I have to pass these secretly to my FastAPI. So how we can do that is, first of all, I can use my configuration file here. So for configuration file here, I can use what I can use is I can use a new module, which is Pydantic settings. So for that, you need to install that. You need to install it using pip. So you can install that using pip install Pydantic settings, and we can start working with that. All right. So for that, you can have from Pydantic settings, and this is going to be Pydantic settings. What we're going to have is just import the base settings right here. All right. Now moving forward, we can import the basic.env module of our Python, and we're going to have load.env function from that to load our env file inside our Python file. I can also import the import OS here, and now I can just simply run the load.env function here to load all my environment variables present inside my .env file inside this file. So now moving forward, we can define a settings class here, and the settings class can be derived from the base settings itself. So for the base settings, first of all, what we can have here is database URL, which is going to be database URL, and there's going to be a string. So this is going to be what is os.get.env, basically how you normally work with a .env file, and that's going to be database URL. All right. So this is going to get the database URL key from my .env file. Similarly, I can get the secret key as well, which is going to be secret key, and it is going to be the secret key for my .env file as well. All right, perfect. And now we can just simply define an instance for this object. So that's going to be settings here. And that's it. Now we can import these settings inside other files and just simply use settings.database URL and settings.secret key to basically access these files here, or to basically access these variables inside that file. So I'm just going to make a very simple fast API here just to demonstrate the purpose of configuration and .env files right here. So from the conf file, what we're going to have is basically the settings here, and the settings I'm going to define the app first of all, which is going to be this. And first of all, I'll show you how does that work. So first of all, I can show you how settings dot database URL looks. So settings dot database URL should return us what? It should return us basically the os dot get env database dot URL right here. Yes, perfect. So this basically creates two layers between sorry for that. Cut. So this basically creates two layers between the .env and your main application, fast application. So this is way secure and should be a good practice inside your production environments. All right, so let's just build a simple root function. So this is going to return what? It's going to return two variables. So first of all, it's going to return db URL. This should not be done anytime, but I'm just doing it for demonstration purposes to display it just in the response itself. So I'm just going to run this file. So I'm going to run this using Uvicorn environ app reload. All right, so as you can see, my application has startup, and as you can see, inside my environ.py, I had printed settings.database URL right here, and this had been exactly printed right here. So that means we are able to access our environment variable using configuration files and .env files itself. So I'll just show you how does this look like, and I'm just gonna go to the root URL here, and as you can see, we have got the two variables inside the response, which is db URL, which is exactly the same URL we had set up inside our .env file, and we had also got the secret key, which is the exact secret key which we have set up inside our .env file. So that's great. We have actually learned how you can work with .env and configuration files for basically handling secrets inside a fast API. Hi guys, welcome back to the channel, and I'm going to show you how you can handle and build customized exceptions inside your fast API. So let's begin. So we're gonna build some custom exceptions inside fast API in this video. So let's start. And so first of all, I'm gonna make my fast API file right here. So I'm just gonna name it something like exception.py, and let's start working. All right, so first of all, obviously I'm going to import the fast API here, import, and also I'm going to import the HTTP exception here to basically refer to different kinds of HTTP exceptions inside this application. All right, so I'm going to make a fast API reference now, and now I can start working with fast API. All right, so first of all, what I'm going to do is, first of all, I'm going to define or basically raise an exception, a customized exception. So for this is going to be an HTTP conception, but the details are going to be customized. So for this detail, I'm going to basically implement a division by zero kind of error. So first of all, I can just do something like /divide, and that is going to be just the endpoint, and I'm going to define the divide endpoint right here. So for the endpoint, I'm going to have two inputs here. So first one is going to be a as float and b as float, and we're going to divide both of them and return to our response. All right, so now what happens is I'm going to check a condition that if b is equals to 0. So what happens is now I'm going to raise a customized exception here. So that's going to be raise an HTTP exception with the status code of 400, and for the detail variable, the detail is going to be customized for me. So the detail is going to be division by 0 is not allowed. So I have built my customized exception here. Whenever the B value is 0, this error will be popped up which says division by 0 is not allowed. So I have built a customized exception here. And if the B is not equal to 0, I can just simply return the result as A by B. Now I'm going to test this application. So I'll just run that using Unicorn, and let's see how this works. All right, so if I go to the docs here and I go to the get divide API point here. All right, so I'm going to use 1 it should simply just return me 1. Yes. And if I choose 0 here, I should get an error here. Yes, as you can see, I've got the code as 400, which is an error code of bad request. And the response body says the detail as division by 0 is not allowed. So this is not a default exception inside Python or FastAPI, but we have built an exception using our own customization. All right, so now I'm going to show you how you can actually again create a whole new exception class inside the FastAPI. So let's begin and start the process. All right, so for this class, what I'm going to do is just how we had raised this exception, which was a HTTP exception, and now we're going to raise another exception, another kind of exception, which is going to be raise not found exception. So this exception, as the name suggests, get raised when something is not found inside the database or something like that. So this is going to be class not found exception, and we're going to have the exception uh, class as the parent class for this written in the parameter of the not found exception. So for the init, I'm just going to init it using the detail, or basically I'm going to init is using the name itself. So self.name equals to name. We're going to have just one parameter. So the name of the object which is not found is going to be present inside the not found exception class. All right, perfect. So now we can move forward. And for now, what we can do here is from FastAPI.responses, we can get JSON response exactly. And also we can have the request from FastAPI. So that's going to be from FastAPI.requests. I'm going to import request. All right, so now we can move forward with app.exception handler. So that's going to handle the exception of not found exception here. So how does it handle it now is exactly what we're going to define in this function. So define not found exception. So handler. So define not found exception handler. How it's going to work is, first of all, it's going to have the request here, which is going to be the request from the server. And then it's going to be the exception here. So the exception is going to be something like not found exception here of the type not found exception. So how does this work is basically now I'm going to just return a JSON response. And how does this JSON response work is JSON response. And now I can define my own status code here. So the status code, just because it is a not found error, so I can use the status code 404. But since this is your customized error, you can actually use any kind of status code, something like 456, 614, something like that. Anything, you can use anything here. So I'll just use 404 for now because that's a not found exception standard. And I think that maintains the uniformity and standardization. So this is the benefit of your customized exception classes, that you can define your custom status codes and then act accordingly if somebody hits on your API and get the response status code as that. And for the content of our exception response, that's going to be something like a message. Message is going to be an F string that's going to have oops, something like that. Oops, this item is not found. So the item is exec.name as we have defined it above inside the exception class. So that can be something like exception.name not found. And that's it. That's great. I think now let's test it out. So I'm just going to I'm going to simulate a database using a dictionary here. So I'm going to use apple 10, banana 20, orange 30. Perfect. So I'm going to simulate that at app.get item/item name here. And then I'm going to define get item. For the get item, I can just have the item name as the parameter which we get from the URL itself, and we can have something like if item name not in items. So now we throw the not found exception here. So how we throw it is basically just raise the not found exception, and in this I'm going to pass the default, which is the initiator class argument, that is the name of the item. So that is just going to be item name. All right, perfect. And if we find the item eventually, then we can just simply return the item and its price as a JSON response. Perfect. So that's how I think we can use our not found exception handler. So let's test it out now. And it's ready. So let's go. Let me just go to the docs. All right. So now we have this endpoint also here. So let's try it out. So for the item name, as we know that we have the Apple item inside our items right now. So as you can see, we got the Apple and the price is 10. We also had the banana. So this should also return us as the banana. Yeah, this returned us. But what we do not have is something like watermelon. So if I try to search watermelon, it should return us an exception as not found. Yes, as you can see, 404 error code is returned, and also in the message we have our dynamic variable watermelon right here. So it says message, oops, watermelon not found. So that's how simple it is to actually make your customized exception inside FastAPI and also make it dynamic using variables inside your requests. Hi guys, welcome back to the channel, and today I'm going to show you how you can handle image form uploads in FastAPI. So what we're going to do here is I'm going to upload an image inside a form inside a FastAPI, and we're going to display it on the next page. So this is going to be a simple FastAPI tutorial where I show you how to handle image submissions on form in FastAPI. So let's begin. So I'm going to make a new file here, something like images.py, and we can start working here. All right. So first of all, obviously, I'm going to import the FastAPI. And also what we're going to have is we're going to have the request and also the upload file function here and also the file function here. And we're going to have the responses. So for the response, I'm going to have the HTML response because we are eventually going to return an HTML page in response instead of a generic JSON response. And also we're going to have the static files imported from the FastAPI.static files because we're going to work with static files, which are actually the images inside this function, inside this application. And from the templating, we can import the Ginger2 templates to work with the HTML templates inside our FastAPI. And now I can just import OS, and I can also import another library, which is shutil. This library is basically used to handle images inside FastAPI uploads. So let's import that as well. All right, so we have done all the imports. Now we can start working with our application. So that's going to be, first of all, I'm going to import the FastAPI as an app, and then I'm going to mount the static folder. So for mounting the static folder, it's basically allowing FastAPI to access the static file directory. So for that, I'm going to do what is app.mount, and then it's going to be the slash static. So the FastAPI is going to mount the static files on the slash static folder, and this directory is going to be the static files object. And now I can refer to the directory of our static folder. So that's eventually going to be the static directory I have developed. I have also declared right here. All right, so this is going to be the static directory here, and now we can move forward, and now we can declare the templates directory. So the template directory is going to be the Ginger2 templates object with the directory equals to template. This is because I have the templates directory in the same path as my file of application, which is present right here itself, which says images.py, and I have the templates folder in the same directory. So I can just simply pass the directory equals to template in the argument of Ginger2 templates object. Now I'm going to declare the upload directory. So this is where all the uploaded files will actually get stored. So this is going to be just simply the static slash uploads, because that is where I'll just store all my uploads eventually. And perfect. So I can move forward. So if I do not have the upload directory already inside my system, I can make that directory using the os.makeDirs upload dir function. And that's all. We have set up all our directories now. So let's move forward. We're actually building a HTML system. So for that, I have already set up some HTML files here. So first of all, I have a form.html here. So this is basically just a form which just says upload image, and it submits the image to the /upload endpoint, which we will develop in a few seconds on our using our FastAPI. And the method is obviously post because we're going to submit the form using the post method. And for submitting the image files or multimedia, you need to also write in another parameter here, which is enctype equals to multipart mart/form data. So this enables you to actually submit images or files using the HTML forms. Also, we just have a simple input here, just a single input here, which is a file type input. And for now, it just accepts image types here. And this is a required input, and this just a simple button for submission of this form. So basically what we get from this file is that it submits the image to the /upload form. So we're going to develop that /upload endpoint inside our FastAPI. All right. So after this, after I've submitted, so I'm going to display my image on this page right here. So this page is basically will display the image and also display its metadata, something like file name, which is file info.file name, and content type is the file info.content type. These are all the Jinja variables. So these are basically the variables which are passed through FastAPI interface. So we'll pass these variables through FastAPI, and these can be accessed inside our HTML Jinja templates. So as you can see, file info will be passed from Jinja, and these are .image URL like .content type. These are all elements inside that file info variable. So we just need to pass that file info, and let's begin how we can move forward. All right. So file info is basically will be a dictionary which will contain all this information like file name, content type, and image URL. All right. So let's move forward. Now we can do what is we just go to images.py and now let's start developing our endpoints. So first of all, I'm going to have the app.get endpoint, and this is just going to be on the root URL, and response class is going to be the HTML response because we're going to return an HTML template from that. So this is just going to be define form page, something like that. And then I'm going to have a request here because that's what you have in default for the HTML response types endpoints of a FastAPI. So for this, for the form page, what we can have is just simply return that HTML page. So for that, we can just return templates.template response and then the name of the template with the context passed here. So I do not need to pass request as a context here, but I'll just pass it for the sake of simplicity. This is not at all required. This will perfectly work if I remove that from here like this, but I'll just pass it to let the response be passed to the context to that endpoint. All right. So now we can move forward and now we can define the actual endpoint for uploading our image URL. So this is the endpoint where the form is actually submitted. As you can see, I think it was form.html. Yeah, /upload is the URL where our form is actually going to be submitted. So for the /upload, the response class is again going to be HTML response because after submission, we have to go to the next page and display that image there. All right, so let's move forward and just define async diff upload, and I can pass the request as the request object, and also we can have file, which is going to be actually the uploaded file here. So I'm going to have the upload file object being called here and unpacked right here. So it is just going to get the file name input from the form, which is exactly the named file here. So this is the file named input from the upload from the form we get from the upload file unpacking. And now what happens is this is actually going to be upload file equals to file unpack. Actually, I'm sorry for the previous info, but this is actually the original format of our uh, file is cut. So file is basically going to be the type of upload file, and this is going to be extracted from the file input. The file input is this because the type is file, and this is going to be extracted from unpacking those file inputs from the form. All right, moving forward. So first of all, what we can do is first of all define a file location. So that's going to be file location equals to os.path.join, and that's going to join the upload directory and the file's name, which is going to be file.filename itself. All right, moving forward, now we can do is we can open that file. So opening that file is basically using the with open function file location, and I'm going to open that in the WB write binary format, and I'm going to open that file as F. And now I'm going to use the shutils function, which is copy file object. So shutils dot copy file object does what? Is basically it will copy the whole content from that file dot file object, and it will copy to the F file location, which is actually the upload directory slash file name inside our local system. So this is going to copy whole of the file content from this to the F location here, and then we can just simply do what is file. We can pass the we can set the context here, where it's going to be file info, and this is going to be something like, first of all, we're going to have file name. So the file name is going to be file name itself, and also can be labeled as file.filename. Then we have another variable as content type, which we're going to display on the HTML. So this is going to be file.content type. And now we can actually have the image URL. So the image URL is basically the path of our image inside our local system. So that's going to be, I'm just going to use a user F string for that, and static slash uploads, because that's where eventually all our uploads are going to go. And then just the file.file name, because that's how we actually save our file using the shutil function. As you can see here, the file location is basically the upload directory and the file.file name. So we write that file to that location using the shutil.copyfile obj function here. All right, perfect. So we have set up our file info, which is the context for our Ginger template HTML. And now we can just simply return it using the return templates dot template response. For the template response, what we can have is the result page, which is going to be the result image.html. And then we can pass in the context here, which is going to be something like, I'm going to pass request as request, and then I can also pass the file info as the file info. So as you can see, we have developed the file info as a dictionary of various names. So for the, as you can see here in the result image, we have extracted all three keys from the file info, which are file name, content type, and image URL, and these will be used as a dynamic variable inside our Ginger templates inside our FastAPI. So let's now run this application and see if it works or not. So I'm going to run it using unicorn images.app, and it runs perfectly. It says application startup complete. So let's see how it works. All right, so as you can see, this is our upload an image form here. So I can just upload an image here, an image here. I'm going to select some image here. All right, so let's just choose this. And I've selected the one.png right here. So I'm just going to upload this here, and let's see. It says image uploaded successfully, and it has got me all the contents for this, which is the file name as one.png, content type is image/png, and the preview of the image also, which is this present right here. And if you see, the URL of this image would be the static uploads/one.png, which is where exactly it has been stored inside my FastAPI system. So that's how you can basically work with images and images in form submission on a FastAPI. Hi guys, welcome back to the channel, and today I'm going to show you how you can implement JWT authentication inside a FastAPI. So let's begin. So first of all, we'll install the requirements required for this. So the requirements are simple. First of all, obviously the FastAPI, and then you can also install Uvicorn to run the FastAPI on your local system, or just run the FastAPI. And then you can also have SQL Alchemy for a test database we're going to create here. And then for encryption and decryption, we can import a library which is called passlib. And in the square brackets, it's bcrypt. So this is the whole library's name. And then we also import Python -jwt. And we'll just install these requirements, and let's move forward with the coding part. All right, so the first part is I'm going to make a test database here. So this is going to be a database for something like users, because we will use JWT tokens to authenticate and validate the user logins. So let me just create some file name database. And already, okay, I already have database, so I'll just name it something like database2.py, and we'll write the database code here. All right, so the code for database is going to be from SQL Alchemy. We can first of all import the create engine. Then we can also get column, integer, and strings to define our columns. Then moving forward, we can import a declarative base for our database. So for importing the declarative base, we can have from SQL Alchemy dot extension dot declarative import declarative base. Moving forward, we can also import session maker from SQL Alchemy. So that is going to help in making sessions for our database. So that is going to be easier to use in our code. So let's just import session maker from SQL Alchemy dot orm. And that's it for the requirements. Now let's move forward. And for the URI, I'm going to just set it something like just on my local host. So I'm not going to connect to an online database here, but I'm going to create the DB file on my local system as only here. So the database file is going to be named as users.db. All right. So moving forward, now we can create the engine for our database, and that is going to be engine equals to create engine, and we're going to have the database URL as the first argument. And then also we're going to have some extra arguments inside this, which is going to be connect arguments. And this is going to be equal to something in curly braces, which is equals to check same thread. So this is a dictionary of additional connection arguments. So the check same threads, I'm going to keep it as false right now. So it basically removes the checking of threads. And then moving forward, we can define a session local here. So session local is basically the database session, which will be used to handle all the queries. And for the base, we can have a declarative base object here. So base is equals to declarative base, and that's it. All right. So that is our database file, and now we can move forward to the next file for our project or implementation, and that will be models.py. So in that file, we will define the models for our application. So that is going to be simple for now. We just have a user database. So I'm going to use a table. So I'm just going to declare one class here itself. That is going to be the user class. So let me just first of all import the requirements. So first of all, we're going to have from database two, which is our database file, the database two. From that, we're going to import the base here. And now we're going to import some column integer strings from our SQL Alchemy. So that will be used to define our table inside our database. All right, moving forward, we can define the user class here, which is an extension of the base object or from our database. And that's going to be something like, now I can declare its parameter, something like table name, which is going to be users, and then ID, name, email, hashed password, and we can remove this column, which is disabled. It's okay. So, and for the name, we can also remove the name here. So we'll just keep it simple. So it just have three columns, which are ID, email, and hashed password. So that's going to be our model for our user database, user table inside our database. All right, so let's move forward. Now we're going to define some auth utils. So that I'm going to create a file which is authutils.py here, and I'm going to define some functions which will be used to encrypt or decrypt or verify the encryptions of our text. So let's define some auth utils here. All right, so I'm going to import the parslib library here, which we installed using pip initially. So from parslib, we're going to import crypt concept first, our first module, and then we can import JWT and JWT error from Jose, which is actually the Python JWT library. And then we can also import something like date time, because date and times will be used to verify the JWT tokens. All right, perfect. So now we can move forward, and now I can define a secret key here, which will be used to encrypt my text messages. So that's going to be something like whatever you like. I just keep it something secret. And then we can select the algorithm. We can define the algorithm variable here. So that is going to be the HS256 algorithm. It is an encryption type. So we're going to use that. HS256. All right, moving forward. Now we can also define our access token expire minutes. So that will be basically the time after which your token will expire once you gain it. So I'll just keep it 30 minutes for now. All right. Moving forward, first of all, I'll define the context here. So this is PWD context. So this is going to be a context object, crypt context object, which will help us encrypt and decrypt our text. So that's going to be a crypt context object with the arguments as schemes, which is equals to bcrypt, and the deprecated is auto. Then we can move forward to define our functions. So first of all, we can define our hash password function here. So hash password function will just simply return pwd contexts hash function, and we'll just pass in our argument, which is password right here. Perfect. Moving forward, we can define another function, which is define verify the hash. So I'm just going to name it something like verify password, and it's going to have plain password and hashed password as both uh, arguments. Moving forward, we can just simply return the pwd context.verify function, which will help us verify both the text using the .verify function. All right, perfect. So we have now verified the password as well. So now we will create a function which will basically create the access tokens for gaining the access to basically to bypassing the authentication or gaining the access to protected routes. So for this, we can have define create access token named function. And for this, I'm just going to pass in a data, which is going to be our dictionary. Then we can pass the expire delta. This is basically the time after which the token expires. And okay, I'll just pass it. This is going to be of the type time delta. And we can pass the default as none for now. All right. So defining the function, we can now declare the variables. So first of all, to encode is basically the data or the password, which is passed as the raw string here. So to encode equals to data dot copy, and then we can set this expire here, expiry time here. Just a second. All right. So the expire is going to be datetime dot UTC now plus the expiry delta. So that is basically the time when our token will expire. All right. So after this, we can also define something like to encode dot now we'll update the to encode. So the to encode dot update, and for the expiry parameter, we're going to update it with expire variable. So that will increase its lifespan or update its lifespan to the new expiry date. Now moving forward, now we can simply encode our JWT. So that's going to be encoded JWT, which is going to be JWT dot encode. And in the parameters, we can simply pass to encode, comma, secret key, which will be used to run the algorithm. And the algorithm is basically the algorithm which we had declared above. And now we can simply return this encoded JWT. So that's it. That's how you basically use Python's JWT and libraries to hash the password and encrypt and decrypt them as well and verify them as well. All right, perfect. So now we can move forward and now we can start basically building our application. One more thing in this is, since we had created the access token, we also need to create a function to decode the access token. So that is going to be something like decode access token, and the argument is going to be token, which is a string. And for this, we're going to put the code inside a try except statement. So that for the try statement, we can have simply payload, which is equals to jwt.decode the token with the secret key and the algorithm, and then it's going to return the payload here. And if it does not work here somehow, so we're just going to throw the JWT error here. Perfect. So that's our auth-utils file. Now we can start building the main app file for our FastAPI. So I'll just name it something like jwt.ui, and let's start building our FastAPI. All right. So first of all, I'm going to import the basic modules here, something like FastAPI depends, HTTP exception, and status as well. And we can import the header as well here. And now we can import the database stuff, which is going to be SQL Alchemy. dot ORM. First of all, we'll get the session. So that's going to be session. And then from the database file, what we're going to get is import session local and the engine of our database. All right. So now from the models, we're going to get the user model. And from auth utils, what we're going to have is auth utils, import all the functions there, which are create access token and verify token, and also the decode access token as well, and also the hash password function as well. We can also get the decode access token here. All right. So moving forward, what we can get is the Pydantic base model as well. So that's going to be from Pydantic, import base model. We do not need the email string here. And also from the FastAPI security module, we're going to get something like HTTP bearer. So that will basically be used for declaring a route as an HTTP bearer route. So that will help us to basically uh, allow us to pass in tokens as inputs, the JWT tokens as inputs for basically authenticating our endpoint. All right, so I'll just pass it as fastapi.security. I'm going to import HTTP bearer. And also I'm going to import the HTTP authorized credentials here. All right. So I think that are all the import statements here. And now we can start the coding. And for this, first of all, what I'm going to do is I'm going to import, I'm going to basically set the base dot metadata dot create all, and the bind is equal to engine. So that basically creates all the database inside our engine. I have not imported base here, so I'm just going to import base here. So the base will be imported from the database file itself. So that's going to be here. And I think that's good. All right. So moving forward, we can now define our FastAPI app, which is simply FastAPI object. And then we can define the security as well, which is going to be HTTP bearer type of security. All right, so now I'm going to define a simple function here, which will fetch us our database. So the getDB function is going to return a database. So that's going to be, first of all, I'm going to have a social session local instance here. And now I'm going to try to yield the database. And finally, we can close the database here. All right. Moving forward, now we can define the schema for our user. So I'm just going to define a schema like user create, because first of all, we're going to create a user inside our table and database. So this is simply going to be username, which is going to be a string, and the password, which is going to be a string as well. All right, moving forward, now what we can do is have a post endpoint here, which is going to be used for signing up. So I'm just going to name it something like slash sign up. And now I can start defining this function, this endpoint. So it's going to be defined sign up, and inside this function, we can pass in first of all the user, which is going to be a user create type of schema. And then we can also pass in the database, which is going to be a session of the getDB dependency. So that's going to be depends on getDB. All right. So now moving forward, we can have, so we can start the logic processing here. So first of all, I'm going to check if the user exists or not. So I'm just going to write in a query to find out if my user exists in the current database or not. So the query is going to be simply db.query on the user table dot filter user.username is equals to our user object's username and dot first. So if basically it exists, then we can give it an error that the username already exists here. All right. And if we pass this condition, that means the username does not exist in the database. So we can start basically hashing our password. So the hashed password is going to be the hash password. Is going to use the hash password function from the auth utils, and we're going to pass the user's password input inside as the parameter. Now what we're going to do is we can simply save our user. So this saved user can be save the command of user, and then username equals to user.username and hashed password equals to the hashed password. All right, that's perfect. So now I can add this user object inside my database. So that will involve the function of db.add_new_user, and then we can commit it here. Then we can just simply refresh it, and then we can return a message something like a username and the ID of that user as well. All right, perfect. So now we can move forward and we can define the post endpoint for our login system. So that's going to be app.post, and I'm going to pass in the /login here. All right, so for the login, what I'm going to do here is, first of all, I'm going to check if the user exists, if the username exists or not. So first of all, I'm going to define the function, which is going to be define login, and then the user, which is just going to have the same schema as user create. And the DB is the same as the session, which depends on the get DB. All right, perfect. Now we can move forward. So first of all, I'm going to check if the user exists or not already. So that's going to be checked by db user equals to db.query. And then I'm going to pass the user table inside this. And I'm going to filter all this table with the fact that user.username is equal to username or not. And if it is equal, then it's great. That means the username already exists and we can proceed forward. But what if it does not exist? That means the credentials are invalid. So I'm going to return an HTTP exception here, which just says invalid credentials. All right, so now we get to the else part, which is basically our user exists in the database. That's perfect. So for this, so basically we need to provide a JWT token as a response in this login endpoint. So basically, whenever a user tries to log in, he can use that JWT token to basically access other protected routes. So this can be used to protect our routes, and each token has an expiry time. So basically, no user can use the same token for infinite amount of time. So that basically enhances the security of our application. All right, so now I'm gonna move forward. I'm gonna use the hashed password here. So for this, it's gonna be db.user hashed password equals to none. Remove hashed password from response, and then I'm gonna create an access token here. So for creating the access token, we can just simply use the access token function here, which is basically this. And for the data, it's gonna be sub. So the sub is basically used for encrypting the data inside of our argument. So you have to pass it in this format itself. So for the sub, it's going to be dbuser.username. And for this username, it will be creating an access token. So once we have the access token created, now we can simply return it using a return statement. So we can return an access token and the token type is bearer. And for this is for the user dbuser. All right. And one more thing is in the verification process, we have first of all compared if the user exists or not, and then we have also verified the password using the verify password function of our auth utils file. So this has verified the password of the original password and the hashed password inside our database. All right, once the hashed password is, we can actually remove this line because we do not need to remove that hashed password. And then we can move forward with our next step. So now I'm going to create a sample protected route here. So first of all, let's just test if it works or not. So I'm going to run this using uvicorn, jwt-app, reload, and let's see if it runs successfully or not. So let's just wait for this to load up. One more thing, for importing the crypt context, we need to use the parslib.context module instead of just parslib. So let's just wait for this to load up now. All right, so I've just imported a wrong function name here. Let me just go there, and it's not verified token. It's actually nothing here. All right, so the application has started up now. So let's just see how it looks like. So yeah, it is available there. I'm just going to go to the UI for a FastAPI backend. And perfect. So we have a UI here. So first of all, I'm going to use the post for sign up endpoint here. So for the sign up endpoint, what I'm going to do here is I'm just going to create a user here. So I'm just going to click on try it out. And then for the username, it's going to be user. The password can be something like pass, and then I'll execute this function. All right, so one more thing, guys, that I had modified the one of the fields inside my user table here, which was email before. So I had modified this to username, and that's it. So now we can see that our user has been created here, as we have got a response with the code 200, which means it was a success. So we have got a username as user and the ID as one, which is the response we had set in the sign up endpoint. All right, so now I'm going to try to log in. And if the login is successful, I should get a response as a JWT token here. So let's try it out, how it works. Let's me just click on try it out, and let's just click on user here, and the password was just pass here. So let's see if it works or not. And so yeah, perfect. As you can see, we have gotten access token as a response here, and this token will be used to access the protected routes inside our FastAPI. And we have got all the details as well, which is hashed password, username, and ID, which are all the correct details for our basically the logic we had processed in here. So that's it. We have learned how we can use access tokens here, and we can generate access tokens using Python JWT. Alright guys, so I'll just show you now how our basic encryption works here. So as you can see, for the hashed password, we have this password right here. So I'll just show you how it changes accordingly with a change in our secret key, which we had basically configured here. So I'll just save my key here, save my hashed password here for now. And now I'll go here. And for the auth utils here, now for the secret key, I'm just going to change this to something like secret key 1234, 124, and let's just let it restart. And for now, I'm just also going to delete this database because I'll just show you how the new secret key works here. So you do not need to delete the database. You can also delete it from some query, but that was more convenient for me because there was just one query inside my database right now. All right. So it has created a new database here, which is users.db here. Perfect. So now I'll just show you how the change in the secret key leads to the change in hashed password, which is basically this here. So let's test it out, and I'll just go here. And all right, so for now, first of all, we need to sign up here. So I'll just click on sign up, and I have already clicked on try it out. So I'll just execute this here, user and pass. All right, perfect. Perfect. We have a user created here with the ID 1 because we had previously deleted the whole database. And now I'll just log in using the same credentials here. Also going to show you how it changes, how it basically returns an error when I give it a wrong password. So yeah, as you can see, it says invalid credentials here. And if I pass the correct credentials here, and I'll execute it now. So as you can see, I've got a different response this time. So let me just check in the hashed password with the previous hashed password here. And so yeah, as you can see, these both are different, and that's because of the fact that we had changed our secret key inside our file here, which is auth utils. So that's how secret key basically um, influences your encrypted password. And also it's the encrypted password, I think, cannot be, the access tokens cannot be same anytime because it also incorporates the time, the current time. So that is why it cannot be same for any two, even two same passwords. So that's how basically the JWT and access token system works. So that's what we have learned. And now in the future videos, we'll learn how we can use the JWT token to basically access a protected route, and also use JWT to hide or protect a route for our fast API. Hi guys, welcome back to the channel, and I'm going to show you how you can use JWT access tokens to basically protect a route, and also tell you how you can access those routes with the help of creating the access tokens. So let's begin. So in the previous video, we have seen how we can basically use the JWT tokens and all the libraries and all the hashings for basically generating an access token and also returning it while we log in on our system. So I'll just show you how it works. So let me just turn my application on here, and I'll just go here. All right, so I'll just reload it. Perfect. So we had created a user previously, which had the username as user and the password as pass. So I'm going to pass those arguments here, and I'll just execute this query. All right, so as you can see, I have got the response, and we have got the access token inside the response as well. So now we'll use this access token to basically protect a route and also With the help of this access token, we'll basically try to access that protected route, and that should basically allow us to access the route because of our access token authentication. All right, so let's begin. So now for the jwt.py, this was basically my file in which I had built my application. So I'll just move forward and build and continue to build the protected route here. All right, so first of all, I'm going to import something which are the optional from typing. And now I can also import the header and the HTTP exception and the status as well. So that's going to be something like from FastAPI, we can import header, HTTP exception, and also the status. All right, perfect. And now we can start building our protected route here. So one more thing I had imported earlier was this, which we're going to use now, which is HTTP authorization credentials from the FastAPI.security package. All right, so let's move forward. So first of all, what I'm going to do is I'm going to define a route. So I'm just going to name it something like app.route, and that's going to be a protected route. So I'm just going to name it something like protected. And then we can move forward and define the route function here. So that's going to be something like protected route. And for this, I'm going to pass in the parameters as first of all, the HTTP authorized, the authorization credential here. So that's going to be HTTPS security. I can just also pass it something like credentials, which are basically going to be an object of HTTP authorization. So that's going to be authorization, and one more second, all right. So that's going to be an object of this, and this is going to be dependent on the security. All right. So let's move forward. And after this, what we can do is, first of all, let's just check if credentials exist or not, because then it will be of no sense to move forward. So if it does not exist, then I'm going to raise an exception, which is something like creds missing or something like that. And then we can move forward with our next condition. So the next condition is basically when we have got the credentials here. So for this, I'm just going to raise the 403 error here because we were not provided with the credentials. All right, so now let's move forward. So moving forward, we can have a token here. The token is going to be the credentials, which is basically the access token which we pass inside the argument there. And then we can have the payload, which is going to be the decoded access token for a token. So we're going to use the decode access token function here, which we created in the previous video in the auth utils file here. All right, perfect. Moving forward, we can now check if payload exists or not. If it does not, then we can raise another exception, which is going to be invalid or expired token. It can also be expired because currently the token is valid for 30 minutes only. Moving forward, if it is all right, that means we have got a valid token, and then we can now successfully return the message here, which is going to be something like protected route accessed, and also we can get the access of the user with the payload sub parameter here, because as we have defined earlier, the create access token takes the input as the data, which is the dictionary of sub. So the sub is basically the user which we are using to authenticate. All right, so this should be able to get us the access to the protected route. So let's see if it works or not. All right. So I'll just start the application again, and it has started up perfectly. So let's just check it out. Just a little typo here. I had to write app.get instead of app.route. So let's just wait for this to start up now. All right. All right, so it has started up. So let's see how it looks like. And as you can see, we have gotten a protected route here. So I'll just click on here. And for this, as you can see, if I click on try it out here, I don't have to pass any parameters here. Rather, I have to pass parameters right here, which is authorize. So for this, let's just try first of all logging inside our system. So I'm going to use the try it out here, and I'm going to use the user and the pass, which are the correct credentials for our user. All right, perfect. So we have got the access token here. So I'm just going to copy this access token, and let's try to access the protected route using this token now. All right, so I'll just enter the token here and just click on authorize here, and perfect. So we have been able to authorize inside the system. So that's why it says log out here. So I'll just close it for now, and I'll just execute it here, and that just says protected route access. For now, if I click on authorize and now click on log out, it will not allow us to access this route. So let's just test it out, and it says not authenticated. Perfect. So that's how you can basically use JWT tokens, access tokens, to basically build a protected route, and also use access tokens from the response to access those protected routes inside your FastAPI.
All right, guys. So now I'll show you how you can create access keys for your AWS account. So head up to your AWS console and then head up to your profile section, uh, your profile down bar, and you can see the security credentials tab here. Now click on that. And now scroll down to the manage keys section and you can click on create access key here. And now it will ask you to create the keys for a particular user. You can select the user for which you want to create some keys, but I'll just select the root user, which has all the permissions. But you can select any particular user which has limited access to the AWS services. So I'll just create a access key for my root user here and I click on create access key. So here's the uh, access key ID and secret access key as well. You can copy these and set up in your AWS configure in a terminal. All right, so the second thing includes is downloading the AWS CLI package. You can install it for Windows through the MSI installer. You can search for AWS CLI install and you can head up to the first link here and now go down in the Windows section and you can head up to the AWS CLI official link, which is present right here. And now you can install it any way you want and you can run this package like this and just follow through all the setup process and install the AWS CLI. All right, it is already installed for me, so it will not walk me through all the steps, but those are just simple steps which requires access to directories or permissions, something like that. For installing AWS CLI in your Linux system, the commands are relatively simpler. So you just have to hit a call request to AWS CLI server, and then you have to unzip the file you have installed here, and then just run this command sudo AWS install. That will install AWS CLI in your Linux system. Alright, so after you install AWS CLI, you can head up to your terminal. You can first restart your device and then head up to the terminal and look for AWS version to verify if AWS CLI has been installed or not. And if you get a version number just like this, that represents that your CLI has been installed. Now for configuring the AWS CLI for multiple services, basically to configure your AWS account inside terminal, you can run the command AWS configure and now you can enter all the access keys and all the secret access and also the region name, which are present right here. As you can see, I've already entered it, so it shows me a value right here, but it will show none if you have entered nothing as of now. All right, so I'll just click on enter because I don't want to change it right now. And AWS secret access key, you'll put the secret access right here. For the region name, just put the region name in which you're working. And for the default output format, you can keep it none as of now. All right, I know AWS has been configured now. So now you can start working with AWS.
Hi guys, welcome back to the channel, and today I'm going to show you how you can connect an AWS MySQL server to your FastAPI. So let's begin. So first of all, I'll head to my AWS account right here, and we can then head up to the Aurora and RDS section right here. So this will have all your DB instances and databases which will be set up right here. So I'll just go inside the database instances here, and then I can create a database right here. All right, so now I'll just create a database here, and then I will choose the configuration for it. So I'm just going to keep it pretty simple. First of all, the MySQL server, and then we can go down and select some other configurations, like I'll just keep it as a free tier for now. Moving forward, for the username, as you can see, I have kept it admin itself here, and for the password, I'll just keep something I'll just you can choose your password right here, so I'll just choose it something like uh, programming knowledge itself, and then we can confirm the password as well. All right, so moving forward, we can move forward. I think we can skip most of these. If you want to configure yourself, you can configure these as well, but I'm just going to skip this for the demonstration purposes. And then if you want to connect it to an EC2 computer resource directly to your basically hosted service, then you can connect it as well from here and just select the EC2 instance here, and it will be connected to that automatically. But for now, we are just connecting it to our fast API, so we do not need that, and we can move forward. And for the public access section, we can set it as yes, because we will be connecting it through our fast API here. For the VPC security groups, I'm just keeping it as default, but you might have other options here which you need to configure again. All right, so for the additional configuration, the port is set to 3306, which is the default port for MySQL server. And the most important thing is setting up a database name right here, because if you do not set up a database name, your database will not be able to connect to any external APIs like FastAPI. All right, so I'm just going to name it something like test MySQL, and then I'll just move forward, and I think everything looks fine here. So I'll just create this database here right now. Then I should, all right, so I'm just going to use the underscore instead of that. And all right, so now let's wait for the database to get created. All right, so for the status, as you can see, the status is creating right now. So we'll just wait when it is totally set up. Till then, we can create our coding script through which we are going to connect our fast API to the AWS RDS MySQL. All right. So for this, I'm going to name it something like AWS RDS, or maybe something like RDS MySQL.py, and we can start coding the stuff. So first of all, I'm going to install some requirements, which are going to be pip install fast API, obviously, and then I'm going to install SQL Alchemy, also PyMySQL, and also Juvicorn for running the fast API. All right. After installing this, we can now start building our database file. So I'm going to create the database file right here. So for the database file, we're just going to basically create an engine here, which will be referred to as engine in fast API's file itself. So we'll just create a basically client, which will be able to connect to the database and then run our queries basis on the fast API's request. All right, so let's start the configuration. So I'm going to import SQL Alchemy first. So I'm going to import from SQL Alchemy. I'm going to import create engine, and I'm going to import, I think that's enough from SQL Alchemy. And then I'm going to also import from SQL Alchemy.org. I'm going to import session maker and declarative base. All right, moving forward, now I can set up my database URI, which is going to be a variable. So that's going to be database URL. This is going to be something like, well, so basically for MySQL, the format for the database URL is basically writing MySQL plus PyMySQL initially, and then you can fill in all the details. So for the details, first of all, we need to write the username. So if the username was admin, as we have set as, which is basically the default username inside our database, we'll just confirm it once the database gets created. And for the password, I had kept it as programming knowledge itself. And then we have to write the endpoint here. So the endpoint will be created after the database has been created. So I'll just write EP for now, and I'll replace it after it has been created. For the DB name, and then after the one more slash, we have to write the DB name, which was test MySQL as we had kept it before. All right, perfect. So now we can set up an engine object here, which is going to be a create engine of the database URL. And then I'm going to create a session local here, which is a session maker object, which just binds to the engine. Then we can set up the declarative base, which is the base equals to declarative base, and that's it. We can set up and get DB function, but we do not need it right here. So we'll just remove that. And now we can simply create a basic file for basically a basic fast API file, which will be able to call this database. So I had already created this file right here, as you can see. So basically to connect to the database, what we do is, first of all, we need to import, uh, as you can see from RDS MySQL, I'm going to import the engine and base, and then I'll just use this function, which is base.metadata.create all bind equals to engine. So this basically creates all the database and also connects to the database using the engine. And also I have used one more thing, that is mods, which is basically the models, which is the user model right here, but we are not currently using it. So I'll just skip it for now, and I'm going to change it to MySQL right here. All right, so basically if our database is connected, we should get this message on the root URL of our fast API. So for now, I think it should not be connected because we had not written the endpoint in our database URL. So I'll just run this using the uvicorn command. So that's going to be uvicorn, and the file name is actually RDS fast, and we have app inside us. We can reload. All right, so I'm just in the wrong directory right now. I'll just, all right. All right, so the application is starting. So let's wait if it starts or not. And as you can see, it was not able to connect to our database. So let's now fix it by entering our connect endpoint for our database. So I'll just refresh it and let's see if our database is created or not. All right, so it is in the status of backing up. So let's just wait for this to get running. So then we can connect it to our FastAPI actually. All right, so as you can see, the database is now saying that the status is available. So that means it is running perfectly now. So we can now copy the endpoint from here and then paste it right inside our database URL right here. All right, so now I'll try to boot my application again and let's see if it connects to the database or not. All right, guys, so as you can see, the application startup has been completed successfully. So now I'll just visit the 8000 port at my local host to check up if the fast API is working perfectly or not. So here it is. And yes, as you can see, it says the message which is connected to AWS RDS and MySQL. So that means the database connection was successful and it is now connected to the database on AWS RDS. Alright guys, so that's how you can connect your RDS MySQL server to FastAPI, and that's it for the video. Hi guys, welcome back to the channel, and today I'm going to show you how you can connect your AWS RDS MariaDB to your FastAPI. So let's begin. So first of all, head up to your AWS RDS console right here, which is present right here, and now I'm going to create a database here. Alright, so click on create database and then just select the MariaDB right here, and then I can select the free tier here and just configure other things. So for the password, I'll just keep it something like admin123. And I'll just confirm that password here. Moving forward, we can select other configurations right here. If you want to, I'll just skip these for now, and then I can make it publicly accessible as well. Moving forward, for the additional configuration, the port is 3306 because this is essentially a fork of MySQL itself. So this will be connected same way we connected the fast API to MySQL server. For the additional configuration, I'll just keep it something like testdb, and that's the database name. And then I think I'll just create this database right here. Perfect. All right, so now we'll just wait for this to be created and let's move to the coding part for now. So I'll create a new file here, which is the AWS RDS maria.py, and then we can start building the database configuration file here. All right. So for this, first of all, we have to install requirements, which are simply pip install SQL Alchemy, the first requirement, and then we also need to install MySQL because eventually we are going to install it the way we had connected the SQL server, MySQL server to the fast API. All right, so I'm going to import create engine from that, and also we're going to import the session maker and declarative base from sqlalchemy.orm. Now we're going to set up the database URL right here. So the database URL is very identical to the URL which we set up in MySQL server. So that's going to be MySQL plus PyMySQL, and then we're going to set up the other configuration. Like first of all, we have the username. So that's the admin right here. For the password, we just set up as admin123, and then we'll just wait for the endpoint right here. Apart from that, the port is 3306 itself, and the database name is testdb only. Perfect. Moving forward, we can declare an engine right here and also a session local here and also declarative base object right here, which will be used to connect to our database in a single go. All right, so moving forward, now I can simply create a simple RDS, a simple fast API right here. So the fast API will just say that I am connected to MariaDB right here, and I'm going to import engine and base from RDS Maria. Then I'm going to set the app, which is fast API instance, and then I'm going to create the database, which is basically base.metadata.createAll, which basically binds the database to our engine. So that becomes a client of that database, and then we can run operations using that client itself. All right, so let's just wait for the endpoint to be generated on our AWS server. So let's just see if it's generated or not. it is still in the process of creating. So let's just wait for this to be completed and then we'll connect it using by MySQL. All right, so we have got the endpoint right here. So I'll just copy this endpoint and paste it right inside my database URI in RDS Maria file. Perfect. So now let's just try to boot up our RDS fast application right here and let's see if it works or not. All right. Oh, so it has stated that application startup complete, which shows good signs that it has been connected to not or not. So I'll just refresh the root URL here. And as you can see, we have got the message that connected to AWS RDS MariaDB, which means that we have successfully connected to the AWS RDS Maria database. And that was our motive. So guys, that's it for the video and thanks for watching. Hi guys, welcome back to the channel. And today I'm going to show you how you can connect an AWS S3 bucket and you basically push objects from your fast API to AWS S3 bucket. So let's begin. So first of all, head up to your AWS console and then search up for the S3 service right here and go inside the bucket list right here. All right, so now we need to create a bucket first of all. So for creating a bucket, click on create bucket right here and then you can select the configuration for this. So for the bucket name, you can just keep it something like test bucket for now, and then we can choose other configurations. So for first of all, we need to unblock the public access so we can basically access it using our fast API. And I think for the other configurations, I'll just keep it as it is. And now click on create bucket right here. Perfect. One more thing that I already have, so there basically the bucket name needs to be unique. So for this, I'll just create something like test bucket um, 234, and let's just see if it exists or not. It also exists. So basically, it needs to be unique globally. So I'll just create something like test pkt 3212. Think this should not exist. Yeah, it doesn't. Okay. Okay. You need to acknowledge it as well. And now I'll think it should be created for us. All right. So the bucket has been created. Let's move on. So for the next part, what we need are the credentials. So for the credentials of our AWS account, basically we need the access key and the secret key for our AWS account. So for getting those, we'll just head up to the security credentials right here. And for the security credentials, I can move down and see the access keys section right here. So I can basically create two access keys at a time. So I'll just delete the elder one here, and I'll create another one right here. So I'm just gonna enter the access key here. So I'm just gonna copy it and paste it right here. All right, so it is deleted. So now I'll just create a new access key here. So I'm going to create here, and yeah, so it has created, as simple as that. So now I'm going to copy this access key right here, and I'll save it inside my Python file. So that's the access key, which is equals to this. Oh, that's actually, oh yeah. So and this is going to be the secret access key. So this is going to be secret key, which is equals to this. All right, perfect. So moving forward, now we can head up back to our S3 bucket and let's start the coding process now. All right, so for the coding process, we can first of all import the Boto3, which is basically used for connecting uh, your Python code to the AWS S3 buckets. And moving forward, now we can simply import the fast API as well. And from fast API, actually, we're going to import from fast API, import fast API file and upload file. So we will basically upload the file on fast API and then we'll push it to the AWS bucket. For that, you also need to install some requirements, so which are basically Boto3, first of all, and obviously the fast API and Ubicorn to run your fast API also. All right, moving forward, now we can also have an exception for Botocore, which is no credentials error, which should not come because we're going to pass the credentials, but let's just use it for our own safety. Then moving forward, we can create an app instance of a fast API, and then now I can create a Boto3 client. So how to create a Boto3 client is very simple. So just just write boto3.client, and then you're going to write your configuration right here. So I'm going to create a client for S3, and then I'm going to I'm going to pass in some other parameters like AWS access key ID, which is the access key, and then the AWS secret access key, which is the secret key. Perfect. Now moving forward, for the test bucket name, I think I had kept it something like test bucket 214 if I'm not wrong. I'll just verify it, 212 actually. All right, perfect. And now I'll just create an upload endpoint for my fast API, so I can basically upload my files to the fast API, which will in turn upload it to the S3 on my AWS. All right. So this is going to be a file object of the upload file, and this is going to unpack the file object. All right. Moving forward, we can first of all try it something like, so I'm just going to use the S3's default function, which is upload file object. So this function is basically used to upload an object to AWS S3. All right, so I'm just going to upload it using the file.file. Then I can configure the bucket name, which is going to be the bucket name itself. And then I'm also going to write in the file.file name as the file name to be stored at AWS S3. And at this point, I can just return a successful message right here. Perfect. And for handling the exception, we can handle the no credentials error exception as something like error credentials not available. As simple as that. Also, our file is ready, our application is ready. So now let's just try to run this application and see if we are able to access AWS S3 and upload the objects to AWS S3 or not. All right, so I'll just run this application here, and the application startup is complete, which is a good sign. So let's see if it works or not. And I'll just go to my /docs for the fast API, which is the Swagger UI, and very easy to interpret as well. So I'm just gonna try out my upload endpoint right here. So for the file, I can just upload a screenshot right here, and let's see if it works or not. All right, so we have got a message that upload was successful, and also the file name is one.png. So let's test if it is present inside a bucket or not. So I'll just open this bucket right here. And yeah, so perfect. As you can see, we've got the object right here, which is one.png. The type of that object is PNG. And we have got all the information about that as well. And if I click on this, I should be able to gather information about this. Perfect. And if I click on the object URL, I think, all right, so I do not have the permission, obviously, because this cannot be accessed publicly through a URL, but that means it is stored inside our bucket of AWS S3. So perfect. So that's how you can use AWS S3 with the your Fast API to store objects on AWS. Hi guys, welcome back to the channel. And today I'm going to show you how you can build a Docker file for a Fast API application. So let's begin straight away. So first of all, you need to have Docker installed in your system. So if you don't know how to install Docker, you can watch our previous videos to refer to that. But I've already installed Docker here. As you can see, I have my Docker desktop open right here. So there are some images right here. So just going to show you how you can build a Docker image for a fast application right now. All right. So for this purpose, I have a sample fast application right here, which is just a simple fast API with two endpoints, which is items and products. So the items just have a dynamic URL that is item ID, which will be printed inside the return message. And that's it. These are just two basic endpoints for a fast API. And I also have a requirements.txt file here, which can be created using the pip freeze command. All right. So let's begin building our Docker file. So for this, I'll just create a file named dockerfile.fast. And now I'll start building the file here. All right. So first of all, I'm going to import the Python's official image. So that's going to be from Python semicolon 3.10. And I'm going to import the slim version of it. And now I'm going to set the work directory for a Django container, which is going to be /app. Moving forward, we can now copy the requirements files. For copying the requirements file, you need to pass in the path of your requirements file. So that is going to be copy.fast/ that's actually going to be /fast/ and then the requirements.txt, and this is going to be copied to the root of our container, which is app. So I'm just going to write it as dot for now because that's in anyways the work directory. Moving forward, now we can run the command which will install the requirement. So that's going to be pip install, and I'm going to install it in the no cache directory form. So that's going to be no cache dir, and then I'm going to have to refer to my requirements.txt file. All right, perfect. Now moving forward, we can now copy the whole of our fast folder here to the root of our Docker container. Perfect. Now we can expose the 8000 port because that is the default port at which a fast API runs. And now we can just simply write down the command for running the fast API for running the fast API applications, which is simply cmd. So I'm going to write the sequence of command, which is going to be unicorn, and then we can have the file name, which is going to be main, and then the application name inside that, which is app. Then moving forward, we can have hyphen host, and then moving forward, we can declare the host as localhost, which is going to be 0.0.0, and then we're going to bind it to a port, which is going to be hyphen port, which is simply going to be 8000. All right, perfect. So now this is the basic command which we're going to run to actually start up our fast API. And that's it, guys. We have built our whole um, Docker file for our fast API. And now I'll just build this Docker image. So how I'm going to build this is using the Docker build command. So that's going to be Docker build -t. And now I'm going to use the image name, which I want to keep it. So I'll just keep it something like fast image. And then I can just refer to the Docker file name. So this is going to be Docker file dot fast, and then I'm just going to pass in a dot to refer to the root. All right, so since I'm using a Docker file which is not default named Docker file, so I have to explicitly pass the -f flag to refer to the Docker file name. So this is going to be Docker build -t, and the name of the image I'm going to keep. So that's going to be fast image. And then I'm going to pass the -f, which will refer to the Docker file name, which is dockerfile.fast, and then the root of the file, which is just the dot. And let's just run this command. All right. So let's wait for this to build, and then I'll show you how does our Docker image looks like. All right, so we have installed the Docker image, or we have built the Docker image. So let's test, let's just see this using Docker images. And as you can see, we have the fast image right here. Perfect. So basically that's how you can build a Docker image for a fast API. Hi guys, welcome back to the channel, and I'm going to show you how you can push and pull your fast API Docker image to Docker Hub. So let's begin. So in the last video, we had seen how we can create a Docker image, and as you can see, I have my Docker image present right here. If I see inside the Docker images, which is the fast image. Perfect. So now I'm going to push this Docker image to my Docker Hub account. So for that, what we need to do is simply we just need to follow some simple steps, and then it will be pushed to Docker Hub, and then we'll retrieve that Docker image from the Docker Hub and then run that image on our local system. So let's begin. So first of all, what we need to do is first of all log in inside our Docker Hub system. So for that, you need to run the command docker login, and this will simply start your authentication process inside the browser. So for running the authentication, I just need to click on enter, press the enter button, and then it will redirect me to the Docker login screen. All right, so I'll just confirm this and now enter my credentials here. If it asks you to, then we can see here that the Docker will be logged in successfully. As we can see, we have got the message of login succeeded. Perfect. And now we can start the process of pushing the Docker image. So first step in pushing Docker image to any cloud server is first of all tagging the image to that server. So first of all, I'm going to tag the image to the Docker Hub. So I'm going to tag Docker tag and then the name of the image, which is, I believe, fast image. Yes. And then I'm going to tag it to the Docker Hub username of mine, which is path2k3 for now, slash and then the name of the image or repository I want to tag it to. So that's just going to be something like fast repo, and then the tag of that image, which I'll just keep as latest for now. So I'll just tag this image and tag tagging is done. So I'll just see my images again and I can see there's a tagged image right here. Yeah, here, right here. So now I'm going to push this image to Docker Hub. So for pushing the image to Docker Hub, we're going to run it something like Docker push and then the tagged image name, which I had kept as path 2k3 slash fast repo and the tag of our image, which is going to be latest. Perfect. So this is how we can push to our Docker Hub. So let's just run this command and it has started the push process. Perfect. All right. So as you can see, the image has been pushed to Docker Hub now, and now we'll see if it is present inside Docker Hub or not. So for that, I'll just go inside hub.docker.com and then I'll sign in to the Docker Hub. So after signing in, I will just be redirected to my repository page. And as you can see, in the last minute, I have pushed a repo right here, which is fast repo, which is actually the repository or the image I had pushed to Docker Hub initially. So this means I have successfully pushed it to Docker Hub, and that's great. Now we can move forward and now we can pull that image from Docker Hub and try to run that image on our local system. So first of all, I'll just delete this image for now, which is tagged this. I'm just going to copy this and just run the command docker rmi. Okay, so I'm just going to delete it forcefully. All right. So now we can pull the image. So for pulling the image, it is the same process as pushing the image, just we're going to replace the push with the pull command. So that's going to be docker pull my username slash my repository name, which is fast repo, and the tag, which is the latest. So this is going to pull the repository from Docker Hub. So let's just wait for this to pull. And yeah, so it has pulled successfully. Now let's see if it is available in the inside the images or not. And as you can see, it is right here. Perfect. So for running this image, what you can do is simply run the command docker run, and then I can bind the port of the image, which can be 8000 port to 8000 port of our container. And then I can write in the name of our image, which is path 2k3 slash fast repo tag latest. All right, perfect. So as you can see, it is running on my local host. And if I go to this link on my browser, I should be able to see, actually, I will be able to see it on our local host 8000 and perfect. I can see it on here and slash docs. I can see the Swagger UI of our fast API, which is exactly the fast API image we had created in the previous video. All right, so that's how you can basically push and pull on Docker Hub your fast API image and basically run it on your local device. All right, hi guys, welcome back to the channel, and today I'm going to show you how you can push and pull your fast API's Docker image to AWS ECR. So let's begin. So in the last video, we had seen how we can create a fast API Docker image. So we had already created the image file, which is here, present right here. And now today we're going to push this image to AWS ECR as well as pull this image and run it on our local system. So let's begin. So first of all, we do have an AWS account setup, obviously, and now I'll head up to my AWS account here. And now, as you can see, I am inside the Amazon ECR service right here, and I do not have any repositories currently. So for building making a repository, we can actually make it through the command line itself. So let's start the process. So first of all, you also need to have Docker installed in your system and also the AWS CLI. So if you do not know how to install that, you can refer to our previous videos on that. All right, so let's begin. So first step is going to be creating the repository. So for first step, we have to configure the AWS inside the terminal. So for that, we need to run the command AWS configure. You will be able to run this command after you install AWS CLI inside your system. So running the AWS configure, and now it will ask you for the credentials. So for the credentials, I'll just go inside the security credentials page, and then I'll go down and go inside the access keys here. So now I'll create an access key right here. Click on this, create access key, and we have an access key present right here. Perfect. So I'll just copy the access key here. All right. So for the region, I'll just keep it as AP South 1 itself. And for the default output format, I'll just skip this for now. All right, perfect. So now we have configured our AWS, and now we can start running our AWS commands inside our terminal. So first of all, what we're going to run is AWS ECR create repository because that's where we will actually store our images. And we're just going to pass in one flag, which is repository name, and that's just going to be fast API, something like that. Repo, I think I have misspelled that. Security, okay, I think I have not configured it successfully. All right, so I have created the repository successfully. Now let's see inside our AWS console if it is present or not. All right, so as you can see, our fast API repository is present inside here. So that means it was created successfully. All right, so now we can move forward. So now we can actually log in our system inside AWS ECR. So for that, I can run a command, which is AWS ECR get login password and then a pipe. Then we can go for Docker login hyphen username, which is going to be AWS. And we're just going to password standard input. Then we can have some credentials from our account, which is going to be first of all the account ID. So the account ID is present inside the IAM itself or actually inside here. Yes, we can see here. So I'll just paste it right here and then I can write in dkr.ecr and then we can write in the region, which is AP South 1. And then I can write in Amazon AWS.com and then we can go with slash and the name of the repository, which is actually this. And I'm just going to copy it here. Or you can simply just copy this whole of this and paste it right here. Actually, you do not need these for logging in. You just need the account ID and the Amazon AWS endpoint. So let's see if it logs us in or not. Yes, it does. So you can see we got the message as login succeeded, and now we can move forward to tag the image. So for tagging the image, first of all, we need to build this image locally. So for building the image, we can run the command docker build -t, then the name of the image, fast image. I'm just going to give it like that. Then the Docker file path, which is dockerfile.fast and dot. So this will create the Docker image on site on our system. In the meanwhile, I'll just copy this URL and now tag this image. So for tagging in, I can run the command. The command for that is docker tag the name of my image, which is fast image, and then that URL, which was present right there, and then just the tag for the image, which is just going to be fast for me. Perfect. So the tagging has been done. The similar command will be done just by replacing the tag with push, and this will successfully push the image to our AWS ECR. One more thing is that you need to remove the image name of your local system. Perfect. So as you can see, it has been removed. It is being pushed to the AWS ECR now. And let's just check out if it is present here or not. I'll just open this here. And yes, as you can see, I have got the fast API image right here. Perfect. So that's basically how you can push the image to AWS ECR. And now we'll just take a pull of that image again. So the similar command is to be run, just replacing push with pull. So I'm just going to run docker pull and the tagged image name. So, so as you can see, we have got the status as image is up to date. So that means this is the same image we had pushed. So that's why it did not uh, update the image. So that just means that it is already present on our system. So for that, I'll just check it using the Docker images. And as you can see, we have the tagged image right here. Perfect. So I'll just copy this image name and I'll just run this image on my local system. Right, so it's actually too big to copy, I think. All right, so this is the name. All right. So, and for this, I'm gonna run it like Docker run and then -p to bind the ports. which is going to be 8000 port to the 8000 port, and then the image name, which is this, with the tag name as well. All right, so as you can see, it is running on our local host. I'll just go to the local host to check it out. And perfect. So the image is running perfectly on our system. And if I go to the Swagger UI, I'll be able to see that it is running there perfectly as well. Perfect. So that's how you can basically push and pull a Docker image of your FastAPI application to AWS ECR and also run it on your local device. Hi guys, welcome back to the channel, and today I'm going to show you how you can deploy a FastAPI image on an AWS EC2 instance. So let's begin. So first of all, I am inside my EC2 console right here, which is uh, referred to as EC2 service present in AWS console. So I'll just head there and go inside the launch instance. After going to the launch instance, now I'll create an instance right here, which can be configured according to you. So I'll just name something like fast. For the OS, I will just choose Ubuntu for now. Moving on, I will keep all other things as it is because I will just make this server inside a free tier eligible space. For the key pair, you can choose a key pair if you want, and this is the most important part, that you need to allow HTTP and HTTPS traffic so that people from internet can actually hit your cloud service. All right, so I'll just launch this instance now, and let's see if it is being built or not. All right, so now let's connect to our instance. It is initiated. So for connecting, I'll just use the EC2 instant connect. So that will basically connect me to the instance inside this browser itself. So I'll just click on connect right here, and I will be redirected to a CLI interface. All right, so this is basically your server. So let's start the process now. All right, so now I can begin installing my requirements. So first of all, I have to install Docker inside my system. So for that, first of all, what I can do is actually sudo apt run the command sudo apt update. And then after this, I can install Docker using the command sudo apt install docker.io. So let's just wait for this to complete, and then I'll install that next. All right, so now I'll run the command sudo apt install docker.io, and I'm just going to pass a Y flag just to affirmate with every requirement of the Docker installation. All right, so I have installed this now, and now I'll start the Docker service by running the command sudo systemctl start docker. So this will start the Docker service inside my AWS EC2 instance. So I basically have to configure the Docker for my user. So I will just run this command, which is sudo usermod -ag docker, and then we can pass in as $user. All right, perfect. So now I will be able to run the commands for Docker, as you can see. All right, so you have to run the commands with the sudo command itself. So for the sudo docker images, I can see I have no images right here. All right, so now I'm going to pull the image from Docker Hub. So I have a test fast repository right here. So I'm going to pull this image from my Docker Hub account. So for that, first of all, what I need to do is run the command sudo docker pull, and then I'm going to pass in my username, which is this, slash the name of repository, which is fast repo, and the tag name, which is the latest tag. All right, so let's just wait for this to get pulled, and then we can begin the deployment process. All right, so it's complete. So now let's just run our fast API using the sudo docker run command. And for the image name, that's going to be my username slash the repository name and the tag as latest. So this shall run my fast application on my local host. All right, so it is running perfectly. So let's see if we can access this on the public IP address of our instance. All right, so this is my instance. Let's see the public IP address for this. This is the IP address, and let's test it out. So for the root URL, I don't think anything should appear. Yeah, perfect. But we should have something present on the 8000 port. So let's check it out. And one more thing, since we do not have SSL right now, HTTP will work. Also, one more thing, guys, that we actually need to run the FastAPI Docker container on the port 80 because that actually is the port which allows for HTTP connections and HTTP basically communication. So that is why we need to bind our port 80 to the 8000 of our EC2 instance, which can be done with the command sudo docker, and we need to pass a p flag, which basically binds the 8000 port to the 80 port, and then we can run the image by its name, which is path2k3/fast repo and the latest stack. One more thing, I just missed the run command here. All right. So it's running completely fine. So let's just refresh this now. And as you can see, I have got the message as hello world, which is what was present inside my fast API initially. So that means we have deployed our fast API on this IP address, which is the public IP address of our EC2 instance. And that's how basically you can deploy a fast API on AWS EC2. And if you want to automate, basically make this fast API service rebootable, you can create a service file which will just reboot your fast API service every time you log off this AWS EC2 instance. Hi guys, welcome back to the channel, and today I'm going to show you how you can deploy your fast API image present inside your AWS ECR account on your AWS EC2 instance. So let's begin. So first of all, obviously we need an EC2 instance to deploy our fast image. EC2 instance right here. If you do not know how to create it, you can just click on launch instances here, and then you can fill in the configuration for your instance, which can be the name for your instance. Then for the operating system, you can use Ubuntu or Amazon Linux, anything you want. I preferably use Ubuntu. Then moving forward, what we can select is the instance type and also the configuration for the system. So I'll just choose that for the free tier eligible ones. Then for the key pair, you can choose a key pair if you want to connect it through SSH from your device. And then you also need to allow HTTPS and HTTP traffics to your AWS EC2 instance so that public can access your public IP address. That's it. And then you can click on this launch instance button, and that will launch your instance on your AWS EC2. All right, so I already have an instance right here, so I'll just connect to this instance. So I'll just click on connect right here, and I will connect that to the instance using EC2 instance connect. So this will basically connect me to this instance inside the browser itself using a CLI interface. All right, so now I'm connected to my EC2 instance, and now I'll start running some commands right here. So first of all, I have to obviously install Docker for this. So for installing Docker, I have to run some commands, which are sudo apt update first of all, to update my repository list. So after we update the repository list, we can run the command, which is sudo apt install docker.io, and I'll just pass the y tag to basically say yes to all the requirements for installing docker.io. And all right, done. So let's move forward, and now let's just switch on our Docker service. So for that, you can run the command sudo systemctl start docker, and this will start up your Docker service. After that, you can also run the command sudo usermod, then hyphen a g and docker, and then I can pass in the $user. So this command basically allows the user to access Docker commands. So basically the Docker commands are accessible to our root user now. All right, perfect. That's great. Now what we need to do is install AWS CLI inside our system so we can actually run some AWS commands like pulling from the ECR. So for that, I have already copied a URL right here, which is we have to hit a curl request to the AWS CLI. So I'll just hit this request right here and cut. All right, so it has downloaded the AWS CLI. Let's just confirm it by running the command AWS version. And it says a version. That means we have actually installed it. Oh, and it also says that we can install it using sudo apt install AWS CLI. So that's one more way to install AWS CLI. And that says that we do not have any candidate because it's the fact that we have installed the zip file. So now we need to unzip this file. So for unzipping this, we can run the command unzip and the name of this file, which we have stored it right here. So I'll just copy this name and paste it right here. Now I'll just unzip this file. So obviously we need to install the unzip folder as well. So I'll just install that using sudo install apt install unzip, and then we can run the unzip command.
right? And after running the unzip command, I think AWS CLI will be installed. As you can see, it is unpacking all the resources inside that zip file. Alright, so as you can see, my AWS CLI is now been installed. So now I'll run the commands using AWS CLI. So first of all, what I can do is just run a command which is sudo /aws/install. So this will basically install the final AWS CLI commands inside my system. All right, so now I can run the commands. Let's see if AWS version runs or not. Yes, it runs, so that's perfect. So now we can move to our next step, which is actually pulling the image from ECR. So I have an image present right here, which is a fast image inside my ECR repository. And I'll just copy the URI for this. And now let's pull this image inside our system. So for that, you can run the command AWS ECR, and then you can run the command get login password. And then you can select the region as your region, which is AP South 1 for me. And then you can put a pipe right here, put a black backslash, and then you can run a command, actually docker login. So the docker login, after that, what can run is the username flag, which is AWS, and then I can pass in the password as the standard input. So this is actually going to be a password flag, and then we can pass in our repository URI, which I just copied from there. All right, perfect. Actually, we need to have the account URI, not the repository URI for now. So let's just see if this logs us inside that or not. Basically, we do not have credentials set up, so let's just set up our credentials first. So for this, I'm going to use AWS configure command. So for the AWS configure, now I can set up my access key and access key ID. So basically, how to access these is you can go inside your account and then you can go to security credentials. In the security credentials, you can go, you can scroll down and you can see some credentials right here. Yeah. And for this, you can do what is select one of these and then delete one of these. So for this, I'll just need to copy this and first of all, deactivate the key. Perfect. And now I'll just paste it here and delete it. All right. And I'll create a new access key here. I just understand this. All right. And there you have credentials. So for the access key, I'll just copy this and paste it here. I think I just, yeah, ZH. All right. And for the access key, I'll just copy this here and again paste it right here. For the region name, I have AP South 1 as the default region, and for the output format, I'll just keep it as none for now. So I'll run the above command again, and let's see if it performs the action or not. All right, so we have to pass sudo for that. All right, so as you can see, I have logged in successfully inside my AWS ECR and AWS account. So now I can proceed to the pulling process of our image. So for pulling the image, we can simply run the command, which is actually copying this URI first of all, and then running the command, which is sudo docker pull, and then just pasting the URI of our repository image. All right, so it says it already exists. So that means it has already been pushed. So let's see if it exists or not. I just run the command sudo docker images and I can see it is present right here. Perfect. So now I'll just run this image. So how to run this image is basically sudo docker run. And now I have to bind my port 80 to the 8000 port. So because 80 port is responsible for communicating with HTTPS and basically making HTTPS requests. So that's why I port my port 8000 to the port 80. And then I will just paste the repository or the image name, and this should be able to run our image. Perfect. So as you can see, it is running on the local host. And now I'll try to access this using our public uh, IP address, which is this. So let's just see if it works or not. All right, so I cannot actually access it on my HTTPS server. So I have to remove the S to make it HTTP. And I think I should be able to access my API now. And perfect. So as you can see, I am able to access this API. And if I go to /docs, this will open the Swagger UI of my Fast API. Perfect. So that's how you can basically deploy your Fast API on AWS EC2 instance. And if you want to make this Fast API running permanently or basically rebooting every time you turn off this SSH connection. So you need to basically build a service file for that. And we had previously built service files for all the Python applications. So you can just refer to that video. Alright, so that's how you can basically deploy your fast API image from AWS ECR to AWS EC2 server. Alright, so that's it for the video guys, and thanks for watching.